Mm.
Research is seeing what everybody else has seen and thinking what nobody else has thought, said Albert Singh Georgi, the Nobel Prize winner in physiology. Having said that, good morning, ladies and gentlemen. It is with great honor and pleasure that we welcome you all to the third Undergraduate Research Symposium on Agricultural Engineering and Environmental Technology 2022, organized by the Department of Agricultural Engineering, Faculty of Agriculture, University of Ruhuna in Sri Lanka. URSAE is one of the milestone academic events of our department, which creates a promising platform for our undergraduates to disseminate their new knowledge and blend with the professionals around the world. It provides an enviable opportunity to learn and foster the ability to be interested in something that enhances the quality of life and strengthen our economy to security in multiple dimensions. This year's event is being organized as a virtual conference with a main theme of Industry 4.0 and Sustainability Towards Innovation-Empowered Nation. We will be conducting the symposium for consecutive 3 days in 3 different thematic areas. Today, you are staying connected with us on the first session of the symposium with the main theme of Industrial Agriculture Challenges, Automation and Precision Control. To begin with, it gives me a great pleasure to welcome all the dignitaries to the inaugural session of the symposium. Today's event is blessed with the presence of our keynote speaker, Dean of the Faculty, senior professors, academic staff members, our young scientists, and my dear students. Ladies and gentlemen, we will begin the ceremony with the university anthem. Let us remain in silence in honor of the university anthem.
Babalana silak dakune Niruan pirikala terane Panuvan oradunu porane Sarasaviyai merune Sarasaviyai merune Vidya Shilpa Kala Danharavat Labamin Dhanamana Karamin Panavat Desa Basarasa Surakina Odatedavat Minisun Vimro Pasasana Gunavat Babalana Sirilaka Dakune Niruvan Pirikala Terane Panuvan oradunu porane Sarasaviyai merune Sarasaviyai merune Yuktiya Shaktiya Bhavaniti Sihikara Dagot Kulamala Patumata Vindahara Namaraka Parasindu Rohana Puravara Hiru Sandu Vemulak Sarasavi Nilambara Babalana Sirilaka Dakune Niruvan Pirikala Terane Panuvan පොරැඳුණු පොරනේ සරසවියයි මේ රුහුණේ සරසවියයි මේ රුහුණේ.
Thank you very much. URSAE 2022 has been honored to witness the presence of eminent researchers and professionals of Sri Lanka and other countries. Ladies and gentlemen, each of you who have virtually gathered on this platform today deserves to be greeted warmly. On that note, I cordially invite Dr. B.M.S. Jinendra, Coordinator, URSAE 2022, to deliver the welcoming address.
Ladies and gentlemen, very good morning to all. Senior Professor S.D. Vanniyarachchi, Dean Faculty of Agriculture, University of Ruhuna, Professor Hemantha Jayasuriya, keynote speaker today, University of Sultan Qaboos University, Oman, Senior Professor C.M. Navaratna, our Editor-in-Chief in Proceedings URSAE 2022, and Mrs. C.P. Rupasinghe, Chairperson Technical Session, all the presenters, head of departments, professors, senior lecturers, my colleague, ladies and gentlemen. I'm pleased to welcome you all to the Undergraduate Symposium, Agriculture, Engineering and Environmental Technology 2022. So first of all, I warmly welcome Senior Professor S.D. Vanniyarachchi, Dean Faculty of Agriculture, University of Ruhuna. Sir, besides numerous other commitments, your presence here added immense meaning to URSAE 2022. So your encouragement as well as well-wishers had always with us and greatly appreciate your presence. You are warmly welcome to the symposium, sir. So today we have with us Professor Hemantha Jayasuriya, Professor in Soil and Water and Agricultural Engineering, an eminent researcher and engineer. Also, he is one of my teachers during my undergraduate career. So, dear sir, I am privileged to warmly welcome you to Symposium. I am sure that your keynote speaker will enlighten a lot of interesting engineering technical avenues to our younger spirit on automation, especially on automation and decision control aspects. Senior Professor C.M. Navaratna, Editor-in-Chief of our Symposium proceedings. Madam, your contribution to the proceeding is greatly appreciated and you are warmly welcome to URSAE 2022. Mrs. C.P. Rupasinghe, Chairperson of Technical Session today. Dear Madam, it is your day today to encourage our younger spirit with your experience. So you are warmly welcome to this session. And Professor G.Y. Jayasinghe, Senior Professor, Head of Departments of Agriculture Engineering, and all the other Head of Departments, Professors, Senior Lecturers, young staff members, and beside all other commitments, you are representing here to witness our commitment in technology advancement and technology development. So it means a lot to us and encouraging very much and greatly appreciate your presence here. You all are warmly welcome to URSAE 2020. Last but not least, our valuable undergraduate presenters in this symposium. So we have with us more than 50 undergraduate students and researchers presenting their first-hand experience in this URSAE 2022 symposium in 3 consecutive days from today. So, dear sons and daughters, so you are the key role players in this event, a symposium. So there is definitely value on it in your work. So that is why we have organized this event at this symposium to present and value your work. So therefore, you all are warmly welcome to URSAE 2022. So very special note, I have very special invited 4 undergraduate students presenting their exciting work today here. So we have with us 4 undergraduate students invited from Sultan Qaboos University. Actually, it was very easy to work with them, work with you, and because you were always on time and so it is very sharp on time and sending all these, responding all the communication and providing these videos and everything. So your presence here will definitely add new value and new tradition to this symposium. So dear daughters, so you all are warmly welcome to this symposium. And dear ladies and gentlemen, so in this year's symposium, so we have selected our theme as Industrial 4.0 and Sustainability toward Innovation Empowered Nation. So I think it is my duty to say a few words about our main theme in this URSAE 2020 symposium. So we know all that, and we have heard this theme, that's this term, that industrial revolution since our childhood. But actually, this industrial revolution has been taken place, our history with different steps, few different steps. So there are a few different milestones. So out of those and the different discoveries, great historical discoveries, there are 4 phases until today. So it was the first phase of this industrial revolution, that Industry 1.0 has begun, believed to be begun in 18th century. So it was 1780 around and 1840 between the first phase of industrial revolution, the Industry 1.0. So that was actually the mechanization, that was based on mechanization. So we have great historical discoveries. So for instance, that the discovery of the steam engine that was improved and invented in 1760, around 1760 and 64 by James Watt. So that was the mechanization phase, the first phase of industrial revolution. And there we had iron, water, and textiles and industries like that. So then the second phase was started from 1840 to around 1950. Yes, so it was about electrification. So electricity played a major role in the second phase of industrial revolution. So it was started with around 1873 with the discovery of Maxwell theory of electromagnetism. So great discovery. And also Michael Faraday in 1831 for discovering the electric motor, and as well as Pixie's dynamo, that he was discovered that the dynamo, that the generator in 1832 around. So that was the second phase of industrial revolution, that is the main theme was electrification. The first one is mechanization. The second one is electrification. So then the third phase of industrial revolution, Industry 3.0, that was believed to be begun in 1950 to 1990. So that era is the electronic era. So the electronic era was started actually in 1948 with the discovery of the transistor by Shockley, Bradin, and Breton. So this discovery was actually the electronics started in 1904 with the discovery of vacuum tube, that is by Ambrose Fleming, but it was not very much efficient. So until 1904 to 1950, it was very slow progress in electronics. But after 1948, when they discovered the transistor, it was the very rapidly progressed the electronics. So after that, and soon after this transistor discovery, that in 1952, that we know that all these scientists, that these 3 teams won a Nobel Prize, as well as then in 1952, Jack Kelby in Texas Instrument, as well as Robert Noyce in Fairchild Semiconductor. That this is around 1950. Now we are talking about electronics era. So they have discovered the integrated circuit. So the integrated circuit was amazing stuff. So that increased the communication power very rapidly. And it was estimated that in that era, so within 18 months, so the speed of the speed of communication by this electronic has been doubled. So so that means by the time that Golden Moore in the semiconductor, Intel founder, so he predicted that since 1950, after 1960 or 70, in this era, within 18 months, the communication power, the speed of communication has been doubled. So that this is the way that we progress our electronic age. So that electronic age was completed around 1990. So until 1990. This is our third place, that is electronic age. So then afterwards, we started this in 1990 to at present, we have this industry.
Recording in progress.
So industry 4.0, that is actually the digitalization age. Now we are in digitalization stage. So I hope that you remember that in 1995 we started in 1990 we started networking facilities all over the world, and starting this World Wide Web, as well as especially the Windows platforms. So hope you remember that our first Windows platform, that is Windows 1995. So that is when they are. So we people has a very easy access to this computing, because with there's very easy user interfaces. So after that there's now you know that today now it is these the digital platforms, how fast and how quickly and how cheaply, how easily you can access with your WhatsApp and all these the remote communication. So country to country, you can it is at your fingertips, so you can very easily communicate. So a few decades ago, overseas communication was terrible, and it was very expensive. Now you see that this technology development, and that is for common popular platforms. Apart from that, in worldwide, scientists have discovered and invented various types of simulation technology and various GIS, remote sensing, and various types of technology based on this digitalization stage. So from now onward, what is the pace? The Industry 5.0. So Industry 5.0 is man and machine cooperation, and human brain working with cognitive computing. So that is from now onward. So ladies and gentlemen, and dear daughters, son and daughters, now you understood that all these technology development was based on millions of discoveries by young eminent the technologies or the scientists. They are working day and night today with tremendous effort. So it is our duty today. So now the world has, our living system has been greatly improved by these and our greatest historical scientists. It is our duty. Our duty today is to have this new way of thinking, so creating new things. So now you know that in Sri Lanka, in critical situations, so we need one or two very big discovery to raise up our economy. So I'm inviting you all to think this day and night. So it would be very small discovery from you to have a very big consequences. You know that now a very simple small discovery of blue LED has made tremendous impact on this our living system. You know that you have these LED bulbs in your home. So that was because of thanks to this technologies in Japanese scientist Fuji Nakamura. So he won Nobel Prize for his finding in 2015. So with that blue LED, small blue LED, now you have these LED bulbs. So it has been estimated that 10 times productivity with LED bulb. So without this LED bulb, that discovery, you might have to pay that 10 times of higher electricity cost for you. So terrible. So therefore, it is very obvious that these today living platforms were greatly supported by these eminent researchers, scientists working hard for the betterment of the society. So I'm inviting our young researchers to think this more and more and act accordingly and your level best. Thank you very much.
Thank you very much, sir, for your warm welcoming. And I think the journey to Industry 4.0 is very clear now. I'm profusely elated to take this opportunity to invite our senior professor, Sudas Divanniyarachchi, Dean, Faculty of Agriculture, University of Ruhuna, to address this gathering.
Thank you, Kirtana.
Good morning to everybody. Our keynote speaker today, Professor Hemantha Jayasuriya from Sultan Qaboos University, Oman, head of the Department of Agriculture and Engineering, senior professors of the department, and senior lecturers, and all the other academic staff, HODs from other departments, academic staff from other departments, students, especially the 4 students from Sultan Qaboos University. First of all, let me thank the organizers of this symposium for giving me this opportunity to give a brief speech. This is held for the 3rd time because this was started during the COVID-19 time, in the height of COVID-19 pandemic situation. So we had to do it virtually, but we are doing it 3rd time also virtually. So hopefully by next year, we will be able to have at least a hybrid event where some of you can be physically present and others can join virtually. Before I proceed with the Department of Agriculture Engineering and its developments and also organization of this symposium, let me tell you about a brief history about undergraduate symposiums, research symposiums of the university and our faculty. Faculty of Agriculture started the undergraduate symposium, presentations from all the final year students way back in 1998, more than 20 years ago. So we were the first faculty of the University of Ruhuna to start an undergraduate research symposium. So now we have gone beyond that. Now we see a department is organizing a research symposium. Now tomorrow we are going to have the undergraduate research symposium of the Faculty of Science. I think it is for the first time, if I'm not mistaken. So that tells you that Faculty of Agriculture has been thinking ahead long time back, and we have been having this for more than 20 years. And for the last 10 years or so, we are having it as a part of our international symposium on agriculture and environment. Earlier, it was just a standalone event. Now we have coupled that with our international symposium. So the need of this separate symposium is clearly understood for this agricultural engineering students, because all the other departments, they get the opportunity to present their research findings. So students, 3 or 4 people, students getting the opportunity, but the agricultural engineering department is leading and coordinating a separate undergraduate degree program, BSc in Green Technology. So there are 50 students. Actually, initial intake is 50 students. Now we have increased the intake to 72. We are not getting all the 72 positions filled, but that is a different matter. So that tells you that if we take only 6 students to present at the international symposium of the main faculty event, there are more than 40-50 people would be left out. So who would be doing good research and also good innovations, but they will miss out. So in that sense, I would like to appreciate the head of the Department of Agriculture and Engineering, Professor G.Y. Jayasinghe, and also the other academic staff members for organizing this undergraduate research symposium for the department. Because there's one other department, Department of Agriculture Economics, so they are also coordinating and leading a BSc in Agribusiness Management degree program. So they might even consider having their own graduate symposium, but this is highly justified. So let me congratulate the department for organizing this event successfully for the 3rd time. Now, and I would like to, I think Dr. Jinendra Sirivijaya talked about the 4th Industrial Revolution and the need to highlight the innovations and technologies to move forward as a nation. So I'm not going to talk about the Industrial Revolution, but let me tell you about the new developments of the Department of Agriculture and Engineering. Now, we have got the government approval to change the name of this department to Department of Agricultural Engineering and Environmental Technology. So we have got all the necessary approval, and the minister has signed the Gazette proclamation. So we are just awaiting the issuance of the government gazette. So then hopefully before the end of this year, we will see the release of the gazette, and there's one other department with the name change. So the importance of this name change is that it would broaden the horizons of this department, bring in environmental technologies, environmental sciences, and various other new technologies where agriculture and environment can work together to address some of the issues in agriculture. So I think students, you are fortunate to have studied in this department, and because we are going forward, and then this would be the first of its kind department in the country. And I can clearly see that there will be increased opportunities for all the undergraduate students and, of course, the graduate students, for those who are in postgraduate, and also staff. So it is up to the department to capitalize this opportunity and also get the maximum out of this, enhancing the scope of the department. And also, I would like to congratulate all the graduates for completing their research projects successfully, despite all the hardships. We were going through extreme hardships since March 2020 with the COVID-19 pandemic, and in the middle of this year, we were going through an economic crisis. So we are still in this economic crisis. We are not out of the woods yet. But with all that challenges, extreme hardships, difficulties, power cuts, and all whatnot, actually, you have been able to complete your degree. So that shows the resilience of your character. And also, I think Sri Lanka is a resilient nation. I think I'm confident that we will come out of this crisis as we have done in the past also. It's a matter of time before we'll come out of this crisis and then move towards our goal to become a developed nation. So let me wish all the presenters and all the attendees a very productive and pleasant virtual stay at this symposium. So thank you very much again for inviting me for this symposium. Thank you.
Thank you very much, sir, for your inspiring words and for enlightening our minds with new insights. I'm honored to invite Senior Professor Champa Navaratna, Editor-in-Chief of URSAE 2022, to unveil this year's proceedings. Madam, over to you.
Thank you, Kirtana. Good morning, dear ladies and gentlemen. Actually, I am honored to avail the proceeding of third undergraduate research symposium in agricultural engineering and environmental technology. That means URSAE 2022. The theme is Industry 4 and Sustainability Towards Nation. Sustainability towards innovation empowered nation. Okay, if I say something about this brief introduction about this proceeding, the proceeding includes 3 keynote speech notes, actually, from 3 eminent scientists in the world, together about more than 50 abstracts from the undergraduates who did their research under agri-engineering department under 3 themes. They are industrial agriculture challenges, automation and precision control, emerging trends in environmental technologies, and innovative technologies in agricultural engineering. Those undergraduates are from BSc in Agricultural Resource Management and Technology degree, and from Green Technology degree program. And actually this time we are very fortunate to have 4 students abstracts from international 4 students abstracts, actually from Sultan Qaboos University, Oman. Actually, it is our great pleasure to have you here for students. Thank you very much for joining with us to present your findings here. And further, yes, I congratulate all of our students actually to do their presentations very well. Thank you very much. Okay, thank you.
Thank you very much, Madam, for giving us a nice brief insight of this year's proceedings. Dear all, kindly turn on your videos to take free screenshots to keep this precious moment as a memory that lasts forever. Kindly turn on your videos to take few screenshots to keep this precious moment as a memory that lasts forever. Thank you. To commence the technical session, I would like to invite Dr. BMS Jinendra, Coordinator, URSAE 2022, to introduce the chairperson of the scientific session.
Thank you, Kirtina. Ladies and gentlemen, let me introduce today our chairperson of technical session, Mrs. CP Chinta Priyangani Rupasinghe, a senior lecturer, Department of Agriculture Engineering, Faculty of Agriculture, University of Ruhuna. Mrs. Rupasinghe acquired her BSc Agriculture from the Faculty of Agriculture, University of Ruhuna, and then achieved her Master in Asia Institute of Technology in Thailand in Agriculture and System Engineering. So Mrs. Rupasinghe possesses a wide range of research caliber, and her major research areas are post-harvest technology and renewable energy. In post-harvest aspect technology, she has investigated aging properties of various fruits and vegetables, and she has studied various mechanisms on refrigeration, as well as several ongoing research been engaged in photothermal applications in food preservation. And research on renewable energy is one of her other favorite research area. So Mrs. Rupasinghe has conducted many number of research on renewable energy, especially solar energy and biofuel assimilation extraction research area. So she started her study on extraction of biofuel assimilation in microalgal sources and a few decades ago, and continuing for studying biodiesel production from underutilized tropical plant materials like oil seeds and oil cakes and all these things. So, and also she has specialized in precision agriculture, and that is also one of her research area. And she has widened her experience on various sensors and transducers and their applications in precision agriculture, especially sprayers and combined harvesters and all. So with that note, I cordially invite you to chair technical session today on the theme of industrial challenges, automation and precision control. Dear Madam, it is over to you.
Thank you very much, Dr. Jinendra. Good morning, all of you. And Dean, Faculty of Agriculture, Coordinator of this Symposium, Dr. Jinendra, and Head of the Department, Professor Jayasinghe, and our today keynote speaker, Professor Hemantha Jayasuriya, and all the professors and all the senior lecturers and all the academic staff of the Faculty of Agriculture, and our graduate, recently passed out graduate from Green Technology, BSc in Green Technology degree program, and the BSc in Agriculture Resource Management and Technology degree program. And also, some students are from the undergraduate students of the Sultan Qaboos University. It's my great pleasure to have such occasion to introduce Professor Hemantha Jayasuriya as a keynote speech of this session one of this URSAE, Industrial Agriculture Challenges, Automation and Precision Control. Actually, he's an associate professor of agricultural engineering in College of Agricultural and Marine Sciences in Sultan Qaboos University, Oman. He's from the Peradeniya University from the Faculty of Engineering, and the professional expertise on design, development, and testing of agricultural machinery, precision and controlled environmental agriculture, and terra mechanics, soil tool and wheel interaction, system analytics and modeling, power energy use in agriculture and bioenergy, ergonomics application in agriculture, and physiological practices and innovative techniques for teaching project types for like those are his research interest and expertise knowledge on those areas. And also he has achievements of he's a member of editorial board in Journal of Agriculture and Marine Sciences, and he's a corporate editor of Journal of Agricultural Mechanization in Asia, Africa, and Latin America, and he's a member of editorial board in Agriculture, Engineering, and International Journal of CITR Journal, and he is the Vice President of Energy, Environment, and Emerging Technology, Asian Association of Agricultural Engineering, and he's the head of the Department of Mechanical and Manufacturing Engineering, Faculty of Engineering, University of Ruhuna, Sri Lanka, and also he's a chartered mechanical engineer in the member of Institute of Engineering. Actually, sir, it's my great privilege to introduce you to today's session. Even he is my one of the prestigious teacher. Therefore, sir, this is floor open for you for the today keynote speech of the session of Industrial Agriculture Challenges, Automation and Precision Control. Thank you.
Good afternoon, everyone. I'm Hemant Jayasuriya. I'm from Sultan Qaboos University, coming for this invited presentation. That I'm actually I'm also I'm born in Matara, and I studied at Ruhuna College, and I went to University of Peradeniya, Department of Mechanical and Production Engineering for my first degree. And then after my graduation, I joined Sugar Corporation. I spent 7 years in the industry. I worked at Kantale and Sevanagala factories. And then later I joined University of Peradeniya again, my department as a faculty, and I spent 10 years. And then later I came to Hapugala, University of Ruhuna Hapugala Engineering Faculty as head of the department, Mechanical and Manufacturing Engineering. And then I moved to AIT, Thailand, Bangkok. I served 8 years as a faculty, and then I moved to Sultan Qaboos University. So I have nearly 20 years of service in Sri Lanka before coming to this level. So today my topic is automation and precision control in agriculture. Will this be the solitary and global solution for accomplishing sustainability and food security in the 21st century? So then we basically our time discussing that we go back and see that what are the serious issues with the food demand and population growth related issues, and then also look at some historical milestones, and then various ways how we can improve the farm productivity in farming systems. And I also, based on my experience, I discussed a few slides on precision farming technologies, protected cultivation, like this vertical greenhouse farming and others. And then under conclusive remarks, we discuss about various solutions for the level of technology we need. So I start with Oman agriculture. So then Oman is an arid country, and also the average rainfall per year is 100 millimeters. No? So you can see very dry climate, and also in the summer, nearly 4 or 5 months, temperature maybe more than 45 degrees. And there are some issues related to irrigation requirements. Still they have agriculture, but very limited arable land areas. So there are issues with the overpumping of water. For irrigation, Omani farmers use either groundwater, desalinated water, or treated wastewater, tertiary treated wastewater. But still this due to overpumping, seawater intrusion has taken place, and then some of the coastal belt, even up to some 1 kilometer or more than 1 kilometer, the salinity problem. You can see some of the date farmlands also abundant. Oman has different type of farming systems. As you can see, The small and medium farms, some farms are grown, they grow vegetables in Wadi areas. Wadi means lowland areas, and also village level using large irrigation, water streams. And also there are medium farms. There are farmers growing tomato, cucumber, and other types of vegetables. But I talk about this, the free trade policy in Oman, that these food materials, even tomato coming from Holland, USA, Spain, India, Pakistan, or various countries, but still these farmers struggle to produce tomatoes, and they struggle when it comes to marketing. So I think here the farmers should be appreciated for even making efforts. And there are private farms. Actually, they mainly produce quality products, and they target export markets. The high value products. Some of the farms have global GAP certificate, and due to irrigation issue, the irrigation scarcity of water, that one of our research, we installed 40 these intelligent energy and water meters in order to check from the using internet to check the water use in these farms, that energy use in these farms. So there is a quota given to farmers based on the land area to use. Even you cannot have your own the well. It will be monitored by the pumping is monitored by the ministry. So there are some developed farms. This farm has even grow carrots with high density, like 20 tons per hectare. They normally grow. So, and they also clean them and sort them, and you can see the desert medic, that they export. So these kind of farming systems are available in Oman. And so then we talk about this word population increase and food deficit, how it is happening. You can see that there is an exponential increase in food demand and also the population increase. But in Sri Lanka, the growth rate is less, not that much, but still some other countries, they have high population growth rate. They are talking about the world demand. Yeah. So then in the same article, I found that 1 in 3 people in the world, it is like 2.37 billion, did not have access to adequate food in 2020. Yeah? There are many other reasons. So I also want to see that what is this land availability for agriculture. So then this shows that 29% is the land, and the rest is sea on earth, and then 71% is habitable lands, and only 50% is used for agriculture. So that is 51 million. But some reason, the 77% of that land is used for animal husbandry, like meat and dairy production. Only 23%, 11 square kilometers used for 11 million used for crop production. So this is one issue. Then if we see what happened to arable land, per capita arable land, in 1960 it was 1.45 hectare per capita, and it has now gone down to 0.66 in 2016. So this is one of the issue. So this 0.66 hectare that you have to grow and produce food for each person per year. So then we see that what things we can do to improve this situation. So we have to be clear with what we really need and what we can do. So it may be country specific. You can see here 77% expected by yield increase, 14% expected by increased cropping intensity, 9% from new lands, new arable lands. In some countries they may have, but in Sri Lanka we don't have. Even the forest lands are taken by some people. You know about Wilpattu, what happened, like that. So then, when with respect to Sri Lankan situation, I think we can do is what we can do is increase yields and increase cropping intensity. Cropping intensity is multi-crops per year. How we can do that? There are some ideas. Like people talk about sustainable agriculture, grow different crops and grow them differently, capitalize on urban farming like rooftop agriculture or urban agriculture. Then there are important things like reduce food waste and cut the meat. Cut the meat means actually they think now 77% land is used for, arable lands are used for meat production, dairy production is maybe not balanced because the meat consumption in developing countries is low. So then, but we need other foods. So, so that is one thing. Then the food waste. Food waste is a very big issue, either post-harvest waste or even some people, they take maximum amount of food on their plate and then maybe 30% of it they throw to the dustbin. So these are one of the research conducted in Oman in our university that we found that 30% food waste by the cooked food. Yeah, so like that. And then we see now what are the strategies or how to solve this problem. So then definitely we need to improve the productivities, even the best use of land, water, and human resources in this venture, and then good agricultural practices, and then quality of produce we need to improve, value addition and processing, reduce post-harvest losses and food waste, I mentioned about it, good supply chain marketing, and then best energy and technology use methods. So these are some of the things we can consider how to improve the yields and how to the productivities. And also when we talk about land productivity or water productivity, so that means the same square meter you should be able to produce more kilograms, or every 1 cubic meter you should produce more kilograms of crops. Yeah, so that is the idea. That's why we start talking about this control environment agriculture, precision farming, smart farming, and various technology adoption in farming systems. So I take you back to historical milestones. So at all these times, the effort was to improve the yield or cropping intensity. So there was a time that people start thinking about having maybe prevent drudgery and difficult farming field activities like harvesting or land preparation. So then people start using machinery and equipment. And then there was a time that people thought that adding fertilizer will improve the yield. And there were other eras like plant breeding, genetic era, herbicide, insecticide, fungicide era, biotechnology era. But now we are in all these things are still on the run, and also we are now in computer and information technology. We can use this information technology to improve. Adopt new techniques. So like control environment agriculture, precision and smart farming. Even people talk about vertical farming or food factory concepts in Japan and some developed countries. And then, but I again talk about this historical milestone that what happened in Thailand. Yeah, that long ago, Thailand was a mostly monoculture systems like rice farmers. So Thailand produced lots of rice and flooded the world market, and the farmers got less money, and they remain poor. So then His Majesty King Bhumibol came up with idea with this diversification, and then he proposed that reduce the rice area. That countrywide it is more than the self-sufficiency level, but reduce that area and diversify the crops. So even he distributed 60,000 farm ponds to dryland areas. So I also did one research in that one. That is actually, you can see in the picture, diversification. Actually, we know every farming system is an economic system. So then the farmers will not system will not be sustainable until it becomes economically better. So this is one of the MSc study what we did. We use optimization using operations research, that how to distribute this subsystems, land area for subsystems. Like we say that rice area should be reduced, but how much we reduce while keeping the farm income high. Yeah. So then there are various types of subsystems: animal, livestock, or aquaculture, or vegetable and horticulture areas, fruit orchards, like that. So then this is one of the outcome we generate, how the land area should be utilized, optimized by improving the various plans we develop. But this is showing one of them, small farm with natural fish feeding. So we found aquaculture generating lots of the income. So we could increase the farm income. Now I go to new technologies, precision farming concept. So precision farming is actually also called the GPS agriculture. And also this, it is about site-specific management. Yeah, these different colors in the distributed in the farm plot is they are actually they have specific management practices. Yeah, so then, but this management practice is supported by cutting-edge technologies like satellites. We can use in GIS maps, and also variable rate technology application of these things. So definition says that the application of an input to a specific area based on the evaluation of variability of the need for the input. So then idea is we collect data of the farmland, and we check nutrient levels, existing nutrient level, existing moisture level, compaction level, and all these data, and we develop GIS map layers, and then we analyze. And then when we come to application for the next season, we only give the balance. We don't over apply any resource. Even the compaction, some areas compacted, we only plow only that area. We save energy. And also, if some areas have already some immobile nutrients like PK, and then we need to apply the balance. And then the next end of the cycle, we keep records. Again, we check the yield data, how the improvements, we do the yield maps, and then we see what happened to the yield distribution among the map. So this kind of things we do. And then in line with them, so I did some research with my graduate students. So this is one of them, actually, to use this small tractor with some sprayer, weedicide applicator, for sugarcane land, young sugarcane plants, so the tractor can move and select these weed patches, green color patches, to apply chemical, not everywhere. Okay, so then not uniform application. These are some of the things we did. We developed some webcam and various threshold levels, and depending on the greenness of the patch, also the different levels of application. So also we did some IoT-based precision irrigation systems. So then the central one computer is doing it, but with communication technology. Yeah. So they're the Zigbee type controller. So, and then irrigation control, precision irrigation control. And then also we did something related to precision transportation planning. So with my sugar factory experience, we found one of the factory in Thailand have a problem of sugar recovery, because of traffic jams. Yeah, like you can see that they use different types of transportation techniques, and then finally end up in queuing there. For example, small tractors here in the front of, like in Sri Lanka, 3-wheelers, and then the large trucks also delay. So then because of that, sugar convert to acids, that during the first 24 hours. So then it is important timely feed in the crushing mill. So we found that actually this transportation cost alone, we didn't estimate what is the sugar level, sugar recovery issues, but the transportation cost for the farmer, it is going to farmer. So then we could reduce 2 million, nearly more than 2 million baht in this case. Yeah, but what we did was we developed some collection centers. So the factory only received large trucks only. So then in the collection centers, intermediate, that the small transportation guys should go there and transfer to the large trucks. So that we reduced that one. And then also we did, this is like maybe 2005, we developed this platform. We call it low altitude remote sensing platform. And it is not like currently sophisticated drones, but what we did required things. We published paper in American Society, the library paper. So this one actually what we did, taking images during the flowering stage, we found that we could predict yield, and also we could predict biomass. We developed some models. We even predict the protein content in rice, and also predict what should be the nitrogen application for the next season. So like that, these kind of things we did. And also the same platform we later used on oil palm pest infestation monitoring. So we use the images from young and matured plants, and then we managed to discriminate that infected plants and young healthy plants, even both category. You can see these graphs, models. So we did those kind of things. Now I move to this control environment agriculture. The idea is actually it is a combination of engineering, plant science, and computer managed control techniques to optimize plant growing system or microclimate, plant quality, production efficiency, yield, and cropping intensity. So that this is one of the green shade house in Oman I visit. And so it can be like a very low tunnel type to very sophisticated greenhouses or fully automated. But in Oman, we found that many farmers start growing cucumber because they can grow year round. During the summer, they give a break. Otherwise, they grow for 4 crops per year. And then they could improve the productivity compared to open field condition to 12 times. So yield increase and also cropping intensity. So if you consider, but in Oman, there is a problem with energy cost. So because of the climate, the solar radiation issue that they use fan pad evaporator cooling system. Of course, there are shade houses also, but they use humidifiers for systems and like that. So compared to situation here, I think in Sri Lanka, we can do lots of things. So if you consider young graduate, consider automation. Now this is a very sophisticated automation system in a greenhouse automation, but you can start with, that Arduino and some kind of microcontrollers to even control the irrigation, control the temperature with thermocouples or thermostats, and then other types of light sensing by having a pyranometer, light level control, having shades, and then what we need is sensors and actuators. So then these kind of things can be done. We need not to go for very high tech, but moderate technology we can use. And then I talk about a little bit on the smart farming. Smart farming is a management concept focused on infrastructure and facilities with advanced technologies, big data, the cloud, Internet of Things. So these are actually kind of a purpose of similar to that precision farming combination of that, but they use tracking, monitoring, automation, and analyzing in order to optimize efficiency. So some of the goals: efficient use of natural resources, availability and increased use of sophisticated information and communication technology. They call them software hardware combination, and analytics. They do the analysis also, that record keeping, record the analysis, and give the prediction. So they give, idea is to give more accurate prediction for the farming system. So then increased facilities need to climate smart agriculture. So then many developed countries start these kind of adoptions. So these are some of the tools: sensors, robotics, AI systems, data analytics. Then all we need is monitors, trackers, and good communication systems, and also clouds, that storage in clouds. And because we use recorded data for the future applications, we do the analysis and then use them for the future seasons. So these are some of the concepts, but everyone, even the developed countries are now concerned about energy conservation. We know that current situation, this Ukraine war and energy crisis, so they always maybe propose this renewable energy use in this kind of system. So even these solar panels are right. There are new technologies coming, more efficient, not like all 20% efficient solar panels, but now new techniques are, new developments are in progress. So these kind of things can come in the future. So we had the opportunity to collaborate, but it's still in progress in the pipeline, this kind of system. So to develop vertical farming system, growth chambers, with other, like in this arrangement, you can see that the idea that there are nurseries and the other facility areas, but growth is done in these growth chambers. So this is fully automated systems. So what I explained what is happening in the growth chambers. So it is like a vertical farming, but they are like crops are on trays. And then they have automated system like heating, ventilation, and air conditioning, HVAC system, and also fully automated thermal conversion element analyzers that actually to maintain the microclimate, even segmental, like you can have compartments within that, even the columns within that having different climatic conditions. So these are some of the futuristic ideas, but one of the Irish island company wanted to collaborate, and they want to check these things in the tropical climate, arid climate. They wanted to have one set up in our farm. So these are some of the vertical farming examples. You can see various examples here in the pictures. You can find them in the internet. But you can see now, if you consider in Sri Lanka, they most are like hydroponic systems. But what type of technology we need? Do we need this kind of very sophisticated technology, automation? No, we can manage with some certain technologies, but still improve the cropping intensity and yield under certain conditions. Yeah? So then this is the area we should think. Now I come to conclusive remarks. So where I answered to that our question, whether we need very high sophisticated technology. So now I give the question again in another form. Can every country in the world need to go for high technology approach? So we know that problems with developing countries, and developed countries can go for these things, but others, what they should go. So then we should have I propose a checklist. Check the nature of farming systems, yield statistics. Check investment capabilities for these kind of new technologies. Check availability of skilled manpower capable of providing services. This is very important area. Now for young undergraduates and also planning to graduate, what kind of product the country needs. Okay, so the graduates with innovative and creative thinking. So actually that some of the courses in nowadays, actually even we went for accreditation and other things, program reviews, they always say that it is not the classroom teaching only, that project-based learning and various types of other type of learning, but the most important thing, you should develop your creativity, creative thinking ability. Always go for innovative items, try to go for innovations. And then we need to check again the readiness of institution providing this support. So not only academic institution, also financial institution. So like, for example, investment capabilities. Now maybe we are in trouble in Sri Lanka, central bank, but still if we always say troubles, and we try to try loans from outside, but why not homegrown solutions? Like I think the agricultural faculties, engineer faculties, and science faculties, they can also contribute for these things. So we know this what we need, modern farming systems and technologies. We need to meet food security goals. So we know that with normal traditional open farm systems, you cannot meet the food. Even for our own population in Sri Lanka, 22 million. That's why we wait for imports, for everything. Need growing, okay, there is another important thing, need growing culture of entrepreneurship development and youth empowerment, even women empowerment, because these are the things, I know that you guys, you want government job. So you struggle for government job. If not, then you don't think about self-employment, or do you start enterprises, small or medium enterprises, group enterprises, that few graduates get together, like for example, one from crop science, soil science, and one from engineering, one from economics, more than sufficient. Even the engineering means they know the computer technology, so then you can form a company and then try to find outsourced jobs, or otherwise you develop your own farm. So, you know what to do. You have the skills, knowledge gathered from your studies, graduate program, undergraduate program. So this culture of entrepreneurship development is very important. And also there should be a government focus on this one, that to support these young entrepreneurs to providing financial facilities and other things, other necessaries. And also the universities should, academic institutions, research institutions should support having maybe forming the incubation programs. So that is actually suppose the young graduate groups, we will be provided financial support, like some kind of salary to form a company. And then the university has all the skilled faculty. So you have some from the economic department, some from food science department, like that. They can give the help to improve the enterprise. So until maybe 1 year incubation period, 1 year, end of the year, they have already generated marketing their products, and then they have some kind of stability and income, and then you release them. They can be standalone system. And then you can get the next batch, that group of things. At least maybe I hope university can provide some funds for the faculties. But my bottom line, there are suggestions. Go for meaningful, appropriate technologies. Don't try to go for very high technologies, very high capital investments, but go for moderate ones. And then also very important for develop competencies, local entrepreneur, competencies of local entrepreneurs, industries, academics, or research institutions. These are, of course, that holistic approach necessary by the universities, faculties, like that. Need to be proactive. I think now we've learned a lesson with this COVID and other political situation in Sri Lanka, financial, economic situation in Sri Lanka. So I think this is the time for academic institutions to train these young graduates for these challenges, skills development. Actually, we need to do capacity building, technology transfer kind of things. So both public, private sector cooperation in this. And also we need another thing, that maybe we have organizations like Ministry of Agriculture, the need to make farming systems ready for adoption for this new technology. So that means availability of investment, finances, and also skills development for even to give training programs for farmers, like that. Even I have some colleagues in Japan, they are doing now, actually they are one of the part of their academic program is train farmers. So they always have outreach programs. Whatever they find new, they invite farmers to see it. So these are some of the things we need to do. And also another thing we need to remember, energy cost and environmental health. So if you damage environment, whatever you do with adopting high technologies, so it will not be sustainable. And also we have to be cautious about energy cost, because we know the expenses, cost of electricity bills, cost of the fuel, and all these things. It is not only Sri Lanka, it is everywhere. Even in Oman, when I arrived here in 2009, now the fuel price is nearly doubled. Yeah, that even the electricity bill has gone up. Even Oman produce fuel, the oil. So it is everywhere. Globally, it is happening. So that whatever you go for, that's why I said meaningful and appropriate technology. So then you keep in mind the energy and also environment. I think that's all from me. I hope you gathered some information and that you can use in the future. So thank you very much. That I acknowledge Dean, Faculty of Agriculture, Dr. Vanyarachi. I think we met long ago when I was at Hapugala. Then head of the Department Agriculture Engineering, and also I especially thank Dr. Jinendra and Chinta, the coordinators. They communicated with me several times and invited me for this occasion. Thank you very much. If you want to contact me, that maybe you can go to my Google Scholar for my publications and other things. I think that will help. Thank you very much.
Thank you very much, sir. Your inspiring speech today on keynote speech on automation and precision control in agriculture. Will this be a solitary and global solution for the accomplishing sustainability and food security in 21st century? It's a really timely, important speech, and also it's help to opening our opening of eye-opening of our graduates recently pass out graduate from green technology and also agriculture resource management and technology. Actually, sir, we are at the mouth of in the threat of food security. Therefore, if we can accommodate introduce a very important technologies, precision farming, control environmental agriculture, and also smart farming. With that technology in the sustainable mode, we have to move to have a successful agricultural production for our food security. So thank you very much. Even if anyone required some more information related to that, you can communicate and you can ask from sir. And also, sir, we wish to have some kind of collaborative activities. Also, sir, in our level, we hope to have some kind of to open up our graduates to global context with the technologies. Even, sir, now world is globalized. Therefore, I think to get your help and your guidance, and we can improve, we can enhance the skills of our graduates. Therefore, sir, if possible, we can open some collaborative activities in research. Actually, sir, we very much wish to have such type of relationship. And even though we know that though you are in different places in the world, you are really concerned on Sri Lanka. Always when you talking with that, you are very much concerned on our country, because we should save our country. That's why, sir, to develop our graduates, please help us for having some kind of internship programs or some kind of collaborative research works. Even, sir, we can work in different places. Even we are in Sri Lanka, you are from Oman or some other places. Even we can do the works with this very highly important. Now ICT technology is very now it's very developed. Therefore, we can use that technology for our future works. Thank you very much, sir.
Thank you, Chinta, and thank you others. If you have any question or anything, even you can communicate with me through email for any support. Actually, last summer we planned to send some students for internship training, externship training to your university, but the COVID and some other protests, I think we could not do that. We still have that secured some funds for that one, maybe next summer, because normally we have this internship program summer. Actually, the Chinta now, University of Peradeniya, I think you know the Dean Agriculture, Dr. Sarath Kolituappa. Earlier he was at SQU, my colleague. Now they through our ambassador here in Oman, they send a kind of signing some kind of MOU for various type of activities. So then the Vice Chancellor circulated it to all colleges and departments, what type of activities we can collaborate, like training, faculty exchange, student exchange, like those kind of things. But it is in the pipeline. We can consider that, Chinta.
Yes, sir. We hope to have a signing in MOU. Actually, sir, we have a first activity, and then we are moving towards, we plan to move towards the MOU. So if it is the time, we can start that, initiate that one also.
Yeah, I'm waiting for actually what is the outcome of the Peradeniya one. So then we can also maybe propose for the University of Ruhuna.
Thank you very much, sir. Thank you very much.
Okay, then thank you. I have some other commitments I have to leave. Also, our students, because this is our mid-semester exam, some of them will attend the 4 projects. So I'm sure some of them will attend. I share with them the links. And I wish a very successful symposium. I think even I discussed with our head of the department. This is very nice program. Actually, encourage undergraduate graduating students this thing, and also for this accreditation issues, they always look for graduation projects, and that graduation projects with the research component. So this is very excellent program. Chinta, I wish all the best with this one. I hope these our graduates will be highly benefited with this kind of programs. They exposed to various types of research, and also Chinta try to invite some other countries. Maybe we will participate next year also.
Okay,
Thank
sir.
you
Thank you very much. Thank you very much, sir. Thank you very much.
Okay, thank you. Welcome.
Okay, then we are moving to the today the technical sessions, starting with the topic a GI-based binary logistic regression model for the inundation analysis, a case study on Alapatha DS Division, Ratnapura, Sri Lanka. Authors are HDM Ekanayaka, ACP Priyankara, and GY Jayasinghe. Now floor is open for this presentation.
Have a nice day, all of you. A GIS-based binary logistic regression model for inundation analysis. This is a case study of Alapatha DS Division, Ratnapura District, Sri Lanka. Here you can see outline of the research, what I'm going to be present. First, brief introduction about the research. Flood is a common occurrence in the world, and it will be most severe and more frequent in future. The reason for that is high population density, urbanization, climate change, and accumulation of value assets. Recorded economic losses due to flood was about 82 billion USD in 2021. Let's move to the local context. Flooding common in Sri Lanka as well. In most of the districts were affected with flood, and among them, Ratnapura is the one of the highest flood occurring district in Sri Lanka. The recorded economic losses due to flood was about 11 million USD. People can't live with flood, so they find a solution like flood mitigation practices and adaptation strategies. For that, flood susceptibility analysis is a necessary prerequisite. There are different technologies to flood susceptibility analysis, such as frequency ratio methods, statistical index method, machine learning techniques, etc. This research focused to create regression model for forecasting future flood susceptibility area. Let's move to the problem statement. When we say over last 40 years, highest rainfall and inundation problems were recorded in Ratnapura district. If its severity increases with time, there is no proper flood mitigation planning still in the Ratnapura district, as well as existing plan being old about 50 years and without any update. And the protection system of this existing plan also provide downstream site of the Ratnapura municipality area. In 2017, 87 deaths was recorded, as well as 2 lakhs of people were affected with flood. In 2003, 122 people were died. But still there is no proper forecasting model for future flooding in Ratnapura district. The main objective of this research is to build up a model for inundation analysis for Alapatha DS division in Ratnapura district, and specific objective is to create GND-wise existing flood area map for Alapatha DS division, considering major flood event in 2017 and resolution 30 meter. How I select the study area for my research? In this slide, you can see flood vulnerability map of Ratnapura district. And highest vulnerability were recorded in Ratnapura, Alapatha, and Nivitagala DS divisions. Among them, 8,000 families with 100% vulnerability were recorded in Alapatha DS division. So I selected study area is Alapatha DS division, which is located in between 6.59 to 6.72 degrees latitude north and 80.29 to 80.47 degrees longitude east, and total extent of the selected study area was about 8,377 hectares. Let's move to the material and methodology. Here I shows the overview of the research methodology to better presenting and understand simply. First, what aspect influence on the flood susceptibility? It was found by literature reviews, and data collection and map generation were done according to the influential factors. Data collection from generated maps were done using ArcGIS software and USGS website. The collected data divided mainly into two parts, training dataset and validation dataset. Using the training dataset, model was built by binary logistic regression model using SPSS software. The created model test with validation dataset and finally finalize the model. Here you can see what aspect influence to the flood susceptibility and its observation methods and information source. Elevation, slope and slope aspect observed by digital elevation model and information source is USGS website. Distance from the river observed by Euclidean distance from river in meter and information source is ArcGIS software. Average annual rainfall observed by rainfall depth in millimeter from 1990 to 2021, information source is Meteorological Department of Sri Lanka. Land use observed by Landsat 8 image and information source is USGS website. Lithology and soil type observed by lithology type map and soil type map and lithology map, information source is GSMB website. Stream power index, topographic wetness index, roughness index, sediment transport index, and NDVI were calculated using this equation, which is shown in the second column of the table, using digital elevation model and ArcGIS software. Flooded area were observed by flooded area map, which is constructed using data received from GND Office of Alapatha DS Division. Let's move the result and discussion. The result of the first step is digital elevation model, and which is constructed using KML file of Alapatha DS Division, which is received from National Disaster Relief Service Center, Colombo, Sri Lanka. Using the created digital elevation model, map A, slope map, map B, elevation map, map C, aspect map, map T, stream power index, map E, topographic wetness index, map A, topographic roughness index, map G, sediment transport index, map H, distance from the river were calculated in equal interval with 5 classification. Map I, annual average rainfall distribution map. To generate that, I selected 6 weather stations to cover my study area. There were Galaturu Estate, Wellandura Tea Factory, Muttuwaggala, Illubuluwa, Hinguraggala, and Ratnapura. These data were received from Meteorological Department of Sri Lanka, and the map is constructed in equal interval with 5 classification. Using inverse distance weighting statistical tool. It is an IDW tool in ArcGIS software. Map J is flooded area map. This map is constructed using data in 2017 flood event, which is received from Ramanidari divisions of Alapatha DS Division. Next, Landsat 8 image, which is downloaded from USGS website. Using that, map K, NDVI map, map L, LULC map were generated. The map K is NDVI map, which is constructed in equal interval with 5 classification. Map I is LULC map, which has 3 classification as in red color, build-up area, in blue color, vegetation, in green color, in blue color, water bodies, in green color, vegetation. Then how I extracted the data from these raster maps. The raster map named as simple A to simple L overlap together, and using ArcGIS software, and the tool is multivariable into point tool. The point map was generated with all variables. Using this attribute table, all data were collected, and the collected data transferred to the SPSS software. So the total number of collected data was 96,489, Among them, randomly selected 50% of data goes to training dataset and remaining data goes to validation dataset. Using the training dataset, model was built, and let's see what are the data. The dependent variable was the flood data, and other remaining factors comes under independent variable. When we consider the dependent variable, it has two outcomes as flood and non-flood. Flood is coded as 1 and non-flood is coded as 0. To find the relationship between this type of dependent variable with its independent variable, most suitable statistical model was binary logistic regression model. After first application of binary logistic regression model, sediment transport index, topographic roughness index, NDVI became not significant according to the model. So I remove these factors and remaining independent variable checked with collinearity by VIF values. The result can be seen in this table. Then you can see stream power index, topographic wetness index, elevation and slope has higher VIF value which is higher than 10 and tolerance is lower than 0.1. So these factors are these factors has collinearity, but I didn't remove these variables because these are significant to the model as well as literature reveals proves that how important these variables. So I changed these factors likewise. Stream power index, topographic wetness index change as ratio between SPI and TWI, elevation change as log value of the elevation, slope change as tan value of the slope, distance to the river change as 0.1 power of the distance, aspect change as radiant value of the aspect. Then finally, application of the binary logistic regression. The 95 confidence interval final report can be seen in this table. The column B shows the coefficient and next standard error and next significant. Then highest contribution came from build-up area. It had 2.707 coefficient. The meaning of that is when build-up area is increasing, flooded area also, flood susceptibility also increasing. The next contribution came from log elevation value. It was minus 2.254. The meaning of that is when decrease in log value of the elevation, the flood susceptibility is increasing. The next contribution came from tan value of this slope. The meaning of that it was minus 1.018. The meaning of that is when decrease in tan value of this slope, flood susceptibility is increasing. After this generated model test with validation data set, for that I calculated mean standard error. It was 0.031. So mean standard error is lower value. Therefore, the model is acceptable. So the calculated value from the model, which is higher than 5, mostly going to be flood. The calculated value which is lower than 5, mostly going to be non-flood. So I checked the sensitivity of the model by ROC curve. Here you can see ROC curve, and in red color line you can mention the zero sensitivity, and blue color line shows the model sensitivity. Then you can see model is sensitive for the flood susceptibility assessment in alpha DS division. How I quantified by area under curve value, it was 0.724. The meaning of that is that.
Let's move on to the introduction. Most of the world's energy spent for building, heating, ventilation, and air conditioning. By making nutrition building material, envelope, and ventilation system, we can reduce the interheating minimum energy. In building, most of the heat is transferred through its envelope, commonly through the walls. In terms of thermal mass, as in this graph, high thermal mass provide moderate temperature and low thermal mass provide high fluctuating temperature throughout the day. Clay is a naturally abundant material with high thermal mass and high density, which act as a heat buffer. Therefore, integrating the clay to the building material is an effective way to remove the excess heat. A dynamic clay wall panel cooling system is a promising best into cooling using burnt clay panels. It was invented by Professor Ruhuna and architect Automaton. This is the schematic diagram of the system. It consists of two components. First one is the thin fired clay panel, acts as a heat absorption and self-cooling. Second is the continuous positive ventilation supply, provide ventilative cooling for the indoors. This is the fired clay panel made of red clay and the sawdust, and this is how it is fixed as a secondary walling with 2-inch gaps to the primary wall. This is the DCXL fan used to provide positive ventilation, and this is how it is attached to the building and the system. Active cooling methods like fans and air conditioner consume high energy and high force. Therefore, using a hybrid cooling technique which consists both mechanical and natural forces can reduce the use of energy and cost. This research used design build modeling and simulation tool, which is useful for evaluating, optimizing, and analyzing energy and environmental impact, and also consider as an effective and cost-saving solution to test the vast range of data within a reasonable time. As tropical region located near the equator and the effects of the climate change leads to the increase in the indoor temperature, which cause uncomfortable living environment. Therefore, active thermal modification systems are adopted, which are less environmental friendly, high cost, and high energy consuming. Therefore, sustainable solutions can be adapted to overcome these issues. My research objectives are to identify the effectiveness of the dynamic plate wall panel cooling system on indoor air temperature reduction based on the area of application, and to identify the direction of applying the clay wall panel with concern to the air temperature reduction, and finally to identify the best proportion for minimum life cycle cooling of internal clay wall solution. This is the methodology flow. Initially, on-site data collection was carried out in a prototype building located in the Putani district, Sri Lanka. This is the real scale prototype building, which is 79 feet square area and 9 feet in height, finished with a single pitch roof, having another pitch roof to cover the veranda area and oriented as a narrow facade facing east and west direction. The required temperature data were collected using the GraphTech Mary Rocker. The other basic data is also collected. Followingly, the model was developed using the design builder software with obtained actual data. These illustrations shows the initial model developed. The hourly weather data conditions were calibrated initially to actual situations, and the components details were inserted as required. The model was initially calibrated for without panels and without fan scenario and continued for the secondary panel application. After applying secondary panel for a panel to fan situation to the west wall of the prototype building, the model also further developed. Again, the model was calibrated for 8 panel to fan scenario. As the model is now calibrated, it's performed in the same way as the real manner. Therefore, a set of simulations were proceeded initially to observe the temperature reduction for different scenarios, and then for different panel fan ratios to find the maximum panel area and the cooling capacity patterns of the different ratios, and to find the best direction to apply the clay wall. A life cycle costing is the total cost from the beginning to the end use, and is initial maintenance and replacement cost. Most of the methods are used to calculate the life cycle cost. Most common methods are simple payback period, which is the number of years when the money is saved after a renovation will cover the investment. And next one is the net present value, which is the sum of money that needs to be invested today to meet all the future financial requirements as they will rise over the life investment. For life cycle costing, a real active building was selected with an existing air conditioner usage, and assume as one of the walls room was installed with the system in increasing manner of the area coverage from like 20% to 100%. Different conditions and arrangements were considered, like 3 different temperature side points. They are 25, 26, and 27 degrees Celsius, and 2 different operating schedules, which are 8 a.m. to 5 p.m. and 24 hours. 4 cases were selected. Case A, without panel, without fan. Case B, with panels and 1 fan. Case C, with panels 2 fan. Case D, with panels 3 fan. The relevant basic cost details were collected. The model was developed for active building. The required energy details were calculated using the design builder software. This is the model of the active building, and this is the room preferred for walling application. Following assumptions were taken for the life cycle costing calculation, mainly the electricity cost for 1 unit is considered as 12 rupees 20 cents as per the CEB commercial tariff, Sri Lanka, and no inflation throughout the building span of the calculation. These are the initial costs for different cases. Case D seems to have a high value. According to the simulation process and the result obtained, the graph shows the temperature reduction comparison for different scenarios. As you see, this has three sets of graphs for with the whole system and three sets for without the whole system. As the system itself creates a reduction in the temperature, the situation of the fan, situation of the indoor temperature is higher than the outdoor temperature condition without the system. And when one of the component is available, even they are reducing, still it's higher than the outdoor temperature. The effect of the thermal mass, cooling, and positive ventilation created by the support system supported by to reduce the temperature than its actual. For the scenario with the system, cooling loads were obtained and plotted from the design builder. While increasing the area of applying the secondary layer walling without changing the number of fans, this is a reduction. That's a reduction in the cooling load required for the 1 meter scale. As panel increase, it increases the indoor heat absorption. The cooling capacity were obtained from the design builder for different panel fan ratios, and the maximum panel area were calculated for 1 fan, 2 fan, and 3 fan scenario. The table shows the energy that could be absorbed by the system under different scenario for 1, 2, and 3 fan conditions. The cooling capacity values were increasing with the number of fans. And in different fan situation, cooling capacity for 1 meter square reduces with increasing panel area. The figure shows the variation in temperature and ventilation pattern before and after the cooling system application. As we see here, it is evident that the temperature has been brought down using the system. To identify the best direction to apply the secondary wall panel, the building was rotated in an axis as the temperature recordings were obtained and plotted using the design builder software. The lowest temperature readings were obtained when the building was rotated anti-clockwise 150 degrees. This image shows the shading effects as per the rotated angle. Initially, the wall with the system installed located in west. Rotation of the building changed the sun exposure and the intensity in different angles. Therefore, the temperature readings were differing for different angles. Net present value and the payback period were calculated for different cases. The 60 years lifespan was used as mentioned in the business standard. It helps to omit unnecessary calculation. This graph shows the net present value for 60 years for different cases and a different area of coverage along with a different temperature set point and different time schedule. Here the cases with the system shows the reduction in cost compared to the cases without the system. As here, the unit of energy after applying the system in different cases B, C, and D shows the reduction than case C. The shaded areas are the situation where we don't be needing an air conditioner to achieve the required set point. Following the payback period was calculated concerning the system saving per year by each case. This is the payback period graph obtained 4 different cases in different schedules. The time for achievement is increasing with the number of fans along with case B, C, and D in both schedules. It is evident that the system selected for the case study is profitable. Even in harsh climatic conditions in dry zone, the system will grant higher economic benefit and less environmental cost throughout the lifespan. With all the results and discussion, I wish to conclude that the dynamic layer panel cooling system is an innovative intercooling system It is sustainable, eco-friendly, and also energy efficient. The use of the system clearly shows a significant reduction in the indoor temperature. 36 panels three-fan situation is proven as the best configuration to reduce the temperature with minimum cooling load. In concern to the maximum panel area held by one fan is 1.39 meters square, two fan is 2.62 meters square, and three fan is 3.94 meters square. In terms of cooling capacity for 1 meter square, the 4-panel 1-fan situation have a higher effectiveness, and minimum temperature is obtained when the panel arrangement is facing 30 degrees from the east. The economic benefits and the success of the dynamic clay wall panel cooling system is strongly proven profitable. Among all the cases, case B, the system with one fan is recognized as the best saving option comparably. These are my references. Thank you everyone for the attention.
Thank you very much, Ms. Sangaraja, Ms. Siri Sangaraja, for your very valuable presentation currently for saving the energy. Now, this presentation is open for the discussion. Is there any questions or clarification you can ask from Ms. Siri Sangaraja?
Yeah, when this, cooling or the reduction of the heat, so you might also consider about the fans or evaporative coolers or some sort of heat pumps as the primary means of cooling. So therefore, now in your case, you are getting the combination of some insulation or energy efficient stuff as well. What do you think about compared to now, HVAC, heat ventilation and air conditioning, right? So now, what is the most energy efficient system? HVAC or you are this hybrid stuff? Have you checked that one? This is a simulation, right?
Yes.
Have you considered that HVAC system to consider that? Anybody can do these simulations. Well, how practical that is?
In case of HVAC, sir, we can manipulate we can change the temperature as we need it. But in this system, there is a situation we cannot bring down the temperature that much. It is more obvious that we can only bring the temperature down with the without the air conditioner usage. We cannot bring it down more than lesser than 24 like that, because it is somewhere it only maintain the temperature to a particular room, because we don't apply that to the whole house or a open thing. We only apply this scenario to a closed building with a small area. So
That's what I'm asking. That was
Yes.
now you've done great work, right?
Yes.
And then this is a fashion. People are doing this simulation. So I'm just asking, what is the practical applicability? If you cannot reduce that level, you cannot, market or you cannot sell your product, right?
Yes.
Then people will ask, what's the point of doing this one?
This is an sustainable solution. So if we use the high, of course, we can adapt to the heating and HVAC system, but using the adapting a clay panel and combination of active positive ventilation, this can most of all, not all the people around all the area cannot adapt to the
So that's another one. Now, now we are not in this stone age, right? Now
Yes.
we are in the 21st, 22nd centuries. Is this convenient? People will adapt this one? Will they use this clay stuff? What do you think? People perception. You can model, you can simulation, whatever, but the people should buy. So their perception is important. What do you think as a scientist? My last question.
Perception, so it depends, because not everyone is willing to adapt this one. Not I can say that, because it is also not like convenient thing, but there are some people who we can, as we consider the sustainability way to save the energy, this could be adapted. So these type of things could be advised to be adopted.
Thank you.
Okay, thank you. Siraj, even another question, that how many degrees you can decrease the temperature in the with this clay wall panel?
Only with a clay wall panel, it is we can only reduce like 1 degree to 1.5 degree only. But when coupling it with an air conditioner and doing it, we can bring that up to 3 degree reduction.
Do you know what is the principle behind that cooling effect of clay wall?
It is a stack effect. Stack effect is included. The cool air is cool air is absorbed by the panel and it is cooled by the system.
Okay, then how you prepared that clay wall? Did you prepare by yourself or you get it
No,
from?
it wasn't prepared panel. As I mentioned, it was invented by my co-supervisor.
How about durability?
Durability, it is considered as a sustainable thing because we consider it as because it as it's attached as a secondary panel to a building in a permanent way can be durable until it's in the building lifetime.
Okay. Okay, thank you very much.
And I have a small question.
Okay, okay.
If I have time. And Skandaraj, did you consider about the outside wind blowing count in your simulation?
No, sir. In the initial recordings and everything were taken while the building is fully sealed. Only the building is fully closed while taking all the data.
Yes, even you fully closed, the fan will have impact on this outside wind blowing. Yeah. So now let's say that completely close the chamber and you are drawing out the wind with the fan, and across the opposite direction wind blowing will disturb the flow, the flow by active flow by the fan. So that will make impact. So you count the shading, but I can't see that you are counting this wind speed. If we are using the wind fan, whether it is active or passive, or the ventilation, that I think you have to take some certain account in wind blowing, because now I saw that your model, that is the surrounding ambient environment is the empty space, the white spread. There is a more possibility to have strong wind blowing, and I think you have to think about it in future.
Even I believe that relative humidity of the air also affect on that.
Yes.
Yes. Thank you very much. Now time is over for the discussion. Thank you very much, Ms. Sangaraja. Then we are moving to next presentation. Topic is on a simulation study on thermodynamic heat reduction in a tropical building with facades opening in multiple levels. By this presentation, the authors are Anton Nirojan, R.U. Halvatura, and G.Y. Jaisingh.
Good morning, everyone. I am Nirojan. My research topic is a simulation study on thermodynamic heat reduction in a tropical building with facade open in multiple levels. Those are the outlines of my research. Introduction, problem statement, the objective of study, material and methodology, results and discussion, conclusion and reference. Introduction. Climate change is one of the most important global issues. Global change is cause increase the temperature across the building, which lead more heat waves and increase the indoor heat. The building envelope is the most important element regarding to the total energy balance of building, especially the building sector, among the around 40–50% of energy consumption. Building elements play a major role in the energy consumption process. Windows are considered most important functional element of the buildings. Windows characteristics, dimension, orientation, and position of building facade are considered most important factor influencing the performance of windows. The energy consumption is determined by many factors. In the position of doors opening and orientation in addition to dimension. and area of the opening, and how to use the means of shading and treatment. The environmental performance of the building usually depending on its structural and design characteristics. According to the studies, by 2050, the 1.6 billion people living in the over the 970 cities would be exposed to the extreme high temperature daily base. Structural design can be helped to reduce the indoor inside the buildings. Housing designs such as optimal orientation of building, higher rise homes, and large opening improve the ventilation. Problem statement. There's a few studies based on the opening multiple level methods inside the buildings. There's less study on measuring the effectiveness of the building-based orientation, based window and door position. There are no identified key introduction techniques for the application of tropical climate. Objectives of the study. Aim of the research is to test efficiency of single-story building with effective window size and position of implementations. The specific objectives are to identify the effect of the facade opening on multiple levels for indoor heat reduction in tropical climate, to identify the effectiveness of window and door positions for single-story building in the tropical area, to identify the thermodynamic pattern in the building interior affected by facade openings, to identify the best potential height for facade opening, facade size, and facade location in terms of heat reduction with simulation study. Material and methodology. On-site data collection, building model development, calibration and simulation, analyze the data and conclusion for the best figure of for optimal window level. Study area. The on-site data collection will be carried out where the building is located in Puttalam district in Sri Lanka, which annual temperature to 29.9 Celsius and rainfall 1,358 millimeter per year. Study area. The on-site data collection will be carried out where the building is located in Puttalam district in Sri Lanka, which annual temperature 29.9 Celsius and rainfall 1,358 millimeter per year. Data collection. Two types of data we collected: primary data and secondary data. Primary data is air temperature for each site. Primary data were recorded by usually graphic midi local for temperature measurement, and continuously we at the 1 hour interval from 7 a.m. to at next day 7 a.m. on clear day. The data was collected during the dry and hot weather data. Those are the data type. Those are the my data collected data. Secondary data. Secondary data will obtain from the Energy Plus data. It's the file from UPA from weather data file. Building model development. The methodology is based on the evaluation of energy performance in the residential home located in Puttalam. The integration of architectural solution for opening design in the facade by evaluation of influence the change of orientation, window wall ratio, window size, shape, and position with each other to reduce the required energy without affecting architectural concept of the building envelope. Those are my room plan. This is my room plan of simulation to my research. Building model development by design builder software. Model of the residential room is one-story structural building. The dimension of this room are chosen as a 4x4 length with height respectively. The following material we are used to create the models of elements. The window opening place is only one side. This is the view of the model view. The window dimension of the height and weight. The window dimension of this height and width are 1:1. the indoor height, door height, and the window dimension of the height and width are 1:1, and then door height is and width are 2:1. In the is three different positions. Then main window orientations of building in west, north, and east. Optimal orientation is simulated by design builder software. This figure show the different position of windows and doors. This figure show the different position doors in for used by design builder software. This figure show the different level of window positions. Calibration and simulation. Among the several tools I used the design builder software. Those are the functions we can gain from the simulation part. This is results I got from each and every simulation part. Like that, I got 8 and total 9 research sheets. The graph is the results and discussion. The results and discussion. The graph of temperature given an excellent indicator of how much heat is consumed inside the building during the day. This is the red line. Red line is inside the building, and this is a red line. Show the outside of the temperature, and green line show the inside of the temperature. This is a results show the average indoor temperature variance depending on where the 16 windows are located in the building. This is my first objective: analyze the best window orientation. This investigation aimed to analyze the influence of rotating of. The results indicate the north orientation angle provide minimum indoor air temperature load. The influence of mainly two factors. First is variation of the window position according to the orientation angle of solar rotation. Then second variation, solar radiation intensity which preceded by those windows according to the sun amount and attitude angle. This is my second objective of research: analyze the best window position according to my research. Which window position is the best? I analyze the best. Which one is the best? According to my results, we can see the which window positions are ready. Window temperatures are very minimum. My third objective is analyze the best door position. According to the results, I got I confirm the best door position. The results confirm the lowest temperature obtained from middle door. When we put door in middle of the building, it can be reduce the indoor temperature. This is my conclusion. The following summarize the main conclusions. To make most of the sun for warmth and natural light for our residential core. Main living area should face north in tropical area. The analyze show the best door position in the middle of the wall for tropical area. The window should be toward bottom of the wall, facing north because it's a produce drop in temperature. Those are the reference I used for my research. Thank you.
Thank you, Mr. Nirojan, your inspiring presentation on that thermodynamic heat reduction in tropical building related to the facades opening. And now your presentation is open for discussion. Mr. Anton, what is your suggestion now? If you want to build up a house, what are the places you can suggest to have a window?
Then if you have a single story building, the building door must be in the middle of the building. Is the best way of the door. Then the windows are, if you have a window in direct opposite of the building door, the direct opposite of door is the best method to reduce the indoor temperature.
Okay. When we consider about the direction, north, south, or like this, east, west, like this, with direction.
Yeah, north side is the best for the according to my research. The north side produce a low temperature, indoor temperature.
North side, but your window is on other side, ne? South
yes,
side.
Yes, ma'am. Yeah, south, ma'am.
Okay. If you are in southern province,
it is we maintain in the Puttalam district in.
Yes. You are in any. You are in southern. No. I'm asking another hemisphere actually. If we are in northern hemisphere, no. If we are in southern hemisphere.
Is when we compare with northern side, the others south and east are produce little bit high temperature, indoor temperature in the building simulation part, but it's not actual condition is not. I can tell the actual situation.
You are just using the software, no?
Software, yes, ma'am.
And you know the Anton. So the factors influencing this thermal comfort of building, right? So you know thermophysical properties of the building materials and the building orientation and the ventilation, building space usage, and so those are coming up, right? And now you are only thinking about this door or something. What do you think about these materials and all these things in your simulation? Because the conduction, convection, radiation, so those things happening with these materials. So is it okay without considering these materials, thinking about the openings and everything?
Yeah, according to my research, I consider the same material and same everything is same. Only changing the door and window positions.
Yeah, what is your materials?
I'm use is a cement material for building wall. The roof material. Yes, sir.
Yes, any signal issue?
Yes, ma'am. It's a heavy drain in our area.
Okay, and guessing also have some issues, I think. What is the roof material you are using for this building in your model?
It's a roof material also cement. It's a one store, not the this the box like the box of material. I mean the single story.
Okay.
Oh yeah.
Yeah, that is what these are not proper buildings. These are just experimental units because you cannot use cement on the on the roof, right?
Roof, yeah.
This kind of simulation. That's why I'm asking when you can do whatever miracles with the simulations. When you're putting that into the practice, then the problem arises in the materials and the way of now. You don't know the people's perception as well because people prefer different styles of houses and modern materials, right?
Yes.
And everything. So based on that, these things changing. So therefore, this is a kind of simulation. You have done it for small, maybe experimental unit as well. But you have to do a lot for these coming to this, jump to this kind of conclusions. Put in that. That is not a rocket science. When it comes to tropical countries, the northern parties, you don't need to do research. That is simple stuff for you. Most of the members get the orientation in the north side. You are not going with this, east and other stuff. Your sun is the barrier there. Okay?
Yes, sir.
Yeah. Okay.
Okay. Thank you very much, Mr. Anton. Now we are moving to next presentation. Topic is on assessment of non-point source pollutant loading in the Kalani River base on soil and water assessment tool. SWOT analysis. And by authors are W.D. Madhuvanti, D.Y. Jayasingh, and P.A.N.P. Pereira. Now, floor is open.
I'm W.D. Madhuvanti. I am presenting final research presentation of assessment of non-point source pollutant loading in the Canal River based on the soil water assessment tool. This is the content of my presentation. Non-point source pollution occurs when rainfall or irrigation runs overland, picking up pollutants and carrying them to rivers. Main reasons of non-point source pollution are increasing of agricultural activities and development of urban centers. Soil water assessment tool is the most powerful tool in measuring non-point source pollution, has played a significant role in non-point source research across all over the world. Problem statement: Canal River having the total length of 145 km and 2,292 square km of river basins. About 2,842 industries were located in the river basin. Out of that, 862 industries have been categorized as significantly high polluting industrial activities, and others are categorized as medium level pollutant activities and low polluting industrial activities. SWOT model is a mathematical tool. It is originated in 1996. Main function of this model is predicting impact of land management practices on water, sediment, and agricultural chemical yields in watersheds. Main objectives of my research are to assess applicability and effectiveness of SWOT for nutrient load in the Canal River, to simulate non-point source pollution in the Canal River, and to estimate the pollution according to changing of land use and land cover. This is the conceptual methodology of my research. I have created digital elevation model for watershed delineation and flow direction stream using spatial data, and I have gotten meteorological data and hydrological data. As meteorological data, I have gotten rainfall and temperature. As non-spatial data, using spatial data and non-spatial data, I have created data files and run certain model. This is my study area of Canal River Basin. I have created this study area, and there are 20 sub-basins of Canal River. I have created the map of sub-basins of Canal River Basin. I have created land use and land cover map of Canal River Basin and soil map and slope map. I had to include those map for model setup. Digital elevation model. I have created digital elevation model getting data from United States Geological Survey and soil classification, data bulk density, texture, and saturated conductivity from survey department, and land use classifications data from Landsat satellite images, and precipitation and temperature data from meteorological department, and stream flow data from irrigation department. I have selected 5 hydromet stations for my research. Those are Galigama Station, Angodi Station, Anfield Station, Hangwell and Kitugiri stations. These are my sampling locations. I have selected 3 sampling locations. Those are Mabima, Kaduwela, and Malwana. A stretch of 70.16 km on Canal River taken as study area. Samples were collected 3 days for a month of March and April. 3 graph samples were collected from 3 locations. Location A is a residential area, can be seen around stream, and most of play works are done around area. Location B is situated in Kadua town premises, and location C situated in Pattivila. I have measured total nitrogen. Location C, there are higher total nitrogen I have seen. Locations in location C than location A and location B. I have gotten these details from model setup. There are 19.27 percentage of agricultural land area. So it is a continuous long-term and distributed parameter model. So it subdivides a watershed into sub-basin connected by a stream network and further delineates a hydrological response unit consisting of unique combination of land cover and soils within each sub-basin. Simulation details of SWOT model and setup. Precipitation is in millimeter. Precipitation is 20.972 millimeter, and surface runoff is 1.155, and return recharge deep aquifer is 29.32. A sensitivity analysis should be done to see how successful the model is. These are parameters of sensitivity analysis, R-square and NSE. SWOT calibration and validation. Calibration period is 2000 to 2004. I have used daily data. The calibration period include wet, average and dry years. Simulated and observed results per month were compared by R-square and NSE for the same period. This is the comparison between observed results and simulated results. Poor results may be due to observed concentrations in a monthly basis may have occurred in extreme events, not representing a monthly average value, and lack of data in nitrogen sources, and no absolute criteria for judging model performance. Temporal variation. In this study, non-point source pollution loads was found to occur most during wet season. And spatial variation. Colombo area was identified as major source area of total nitrogen. Nutrient loads change significantly based from interannual rainfall. Main disadvantage of SWOT modeling is that algorithms used are not effective to simulate, validate complex nutrient emissions and transport. This is the end of my presentation. These are references, and thank you.
Thank you very much, Ms. Madhuvanti. The presentation is open for questions, but I heard that she's not available. Someone said that, but the other authors are there. I think, is there any questions you can ask? Maybe other authors participate the event. Ms. Madhuvanti, are you there? I think due to unavoidable reason she may not attend the event. Is there any questions? You can ask. From other authors are there. No questions? Even I'm not sure is that Pereira is available. Is Pereira available? TANT? Right? Then if there are no participation of other authors, even we are moving to next presentation. Design and performance testing of a garden leaf collector. Actually, this is, I want to say a few words before starting this presentation. This is a kind of one of the milestone of our undergraduate research symposium, because this time we are open it up for the international community, actually for the international students. This is first presentation from the international students participated in our undergraduate research symposium. Therefore, actually, I want to especially welcome you for the Sri Lanka, actually through virtual event. Therefore, that authors of this presentation, I am sorry to pronunciation about the name sometimes, Shata Al-Amri and Safa Al-Rashidi and Nusaiba Al-Subi and Hemant Jayasuriya and Saif Al-Adawi and Muhammad Al-Belushi. Then now is the presentation, the time for the presentation.
Hello everyone, I am Shadil Amri and my colleague Shita Rushedi and Nusaiba Subhi from Sultan Qaboos University who want to talk about our project, which is design of a small garden leaf collector machine. We want to express our thanks for our advisor Dr. Himinatha and technician Mr. Muhammad and Mr. Saif for their support and help. First, we'll talk about introduction, problem identification, objective, methodology, result and discussion, conclusion, recommendation, and finally the reference. Introduction. Leaves are part of plant that fall from tree during fall and summer. Leaves can be used to improve soil texture. In addition, sometimes it's used to develop soil fertility. Collecting leaves takes time and it is difficult in some weather, especially at windy days that lead to fall a lot of leaves. There are two kinds of tools and machines that use for collecting leaves. Collector machine can be divided into two types. One type for machine with engine, another type that use manually. Usually people use rake or brush for collecting leaves manually from their home yard, but it takes time, waste effort, and cause back pain. Another type of leaf collector is based on section mechanism. It works with independent electrical engine. It takes leaf off of ground, then take it into tank. This type of machine is used in big area and it is expensive. Leaf blower is other machine can be used to collect leaf. It is expensive and heavy and it blows dust around that may cause negative effect in eyes and limbs. Other machine is lawnmower for mulch leaves, but it's noisy and it leaves the mulch of leaves on ground. Problem identification. The huge number of leaves that fall from the tree in different time of the year, and especially in fall season, people badly make effort to collect them. In the past, people used some manual tool to collect the leaves from the ground like rake and brush, which has many negative effects such as cause some health problem like back pain, record more time, more effort, more labor need to clean one area, less efficient. The main objective of our project is to design, develop, and conduct perform tests on leaf collector machine suitable for small home garden and farms. The specific objective to search a lecture for leaf collector machines and similar mechanisms, to design and develop prototype, to conduct performance tests, to conduct a cost analysis. Methodology.
The information about collecting leaf and its machine were collected using scientific resource. Leaf collector machine was designed with 4 subsystems, which are frame and handle, drum assembly, container and scriber, and leaf collector. The material and fabrication step were identified. The machine was developed. After that, performance tests were conducted, which are mechanical tests, prototype tests, and ergonomic tests. And finally, we get the final model of machine. This flowchart shows the main part of leaf collector machine for every subsystem. This picture shows the overall dimension of our machine. The weight of machine was calculated, which around 31 kilogram. The rolling resistance was estimated using the Beaker theory with the flowing equation, which are around 74 Newton. We assume the velocity 0.56 meter per second. We get the resistive power considering 20% for surface condition and 20% for scriber and container, and we get it around 58.1 watt. The available power is around 74.6 watt. We get the available power more than resistive power, and that means the dimension and weight of machine is valid and good. These two pictures show the prototype of leaf collector machine. This table shows the specification of our machine. The field capacity around 640 meters square per hour. The forward velocity 0.3 meter per second. Overall dimension 77 centimeter length, 37 centimeter width, and 128.5 centimeter height. And then the dimension for each subsystem is shown in this table. The power requirement is 58 watt. The cost of machine around 273 Omani Riyal. One labor per machine, 12. The mechanical efficiency is 12.5 comparing with manual. The first test is mechanical functionality test. It was done in field with 3 replication in one strip with 5 meter in length. And we get the result in this table. The velocity on soil surface around 0.3 meter per second, and the field capacity on soil surface around 640 meters square per hour. While on grass, the velocity around 0.29 meter per second, and the field capacity is 623.6 meters square per hour. These two pictures show the second test, which is performance test. The left for on soil and the right on grass. The result of prototype test is shown in this table. 100 mango leaves were used in every test, and we get on the soil surface the percentage of collected leaf around 59%, and uncollected leaf 16%, and sticky leaf in nails and scribe around 25%. On grass, 33 of collected leaf percent, and 55 of uncollected leaf percent, and 12% of sticky leaf. And third test is ergonomic test, and it was done for 5 people to get appropriate dimension for the handle. I'll get it in the following table, and we get the height from hand, the length of step, length with clearance, and distance between hand, and we get the appropriate dimension for handle. This table shows the right and left hand discomfort, and we get for the traditional it is 3.3 and it is very uncomfortable, while for the machine it is 2.2, it is moderated and comfortable, and is better than traditional way. This table shows the whole body discomfort. For machine it is 2, low discomfort, while for traditional it is 3, medium discomfort, and that means for machine is better than traditional way. This table shows the bill of material and their cost around 40.6 Omani Riyal. The break-even analysis was conducted using annual fixed and variable costs and considering machine life as 5-year. And we get it by the following graph. And we get the break-even area around 2,263 meters square. To conclude, the machine can be operated even by unskilled worker. Average forward velocity is 0.3 meter per second. Its expected field capacity standard is 1,268 meters square per hour for 0.56 meter per second. But for first prototype test of the machine speed was 0.3 meter per second and got 640 meters square per hour capacity. The break-even area is around 15,000 meters square. Recommendation: try it with different type of leaves. Increase the field capacity of machine. Add adjustable wheel to smoothen the idle movement of the machine. Use rubber topping around the handlebar for comfortable use. Further tests necessary after modification and developing the prototype tool. This reference that we used. Thank you for listening.
Thank you very much, Ms. Shata Al-Amir. Thank you very much. It's a very interesting presentation and even very valuable presentation because it addresses really the work to reduce the workload of the human worker. It's a kind of manual working. Therefore, it's very inspiring invention. And then your presentation is open for questions.
Thank you very much, Aisha, your presentation. And it is very interesting application to solve very practical problem. Wherever, even if you are living in a palace, you have these small practical issues. So now in your conclusion, you expected the standard 1,268. So that target based on which type of machinery? That your machine, your machine is working under the capacity of 640 square meters per hour. But you are expecting 1,268 square meters per hour. Based on which standard? Do you have machine operated motorized one or something with that higher capacity?
I think she is muted, right?
Muted.
The capacity we considering the container, the size of container that we decided.
Size of the container based on the previous research or from where you get this standard?
From our estimation.
That is by estimated by mathematically estimated reachable target, right? Is that so?
Yes.
So how about if someone sweeping out by hand, what will be the speed? Now this is, I think to me it is, it is around, it is 640 square meters per hour is, is somewhat good. How about someone sweeping out manually? Did you have any experience? Any data?
Kind of field capacity, no? Manual operation.
Yeah, by manual operating by manual.
By manual, it takes a higher time.
Yeah, much more time. Okay. So what are the other parameters if you increase the drum length, then you will now someone can suppose that by increasing the drum length, you can increase the capacity, and in one way, and so then if you overestimate it and go beyond some certain level, that you will need more power, and then ergonomics will play again negatively. And then drum diameter, that if you get a small diameter, that you will not be able to collect small leaves, right?
Yes.
Drum weight, that if you have less drum weight, so then that spike will not penetrate the leaves, right?
Yes.
So what are the improvements you will be able to you will target in future?
To add two wheel, that will the moving will be easier. And also we can increase the capacity. So when we have wheels and high capacity, we can improve this machine.
Okay, thank you so much.
And I have a few questions as well, right? So what do you think now? Is it collecting, you are using, now normally there are some suction tubes and sucking things. So have you checked with that? Is it just, just dragging and collecting? Now there are some, leaf collectors. Now you the suction tubes and you just can suck it there. Have you checked with that kind of stuff? Okay, next one now. There are different types of leaves, right? Broader leaves and tiny stuff. So have you now? You only done this for mango, okay?
Yes. We do
And
it for mango.
what about the moisture content or the maturity of the leaves? So have you done that on the leaves architecture or something?
We use some leaf it is very dry and some leaf it is not very dry. So when you have very dry leaves, some leaves is broken. So it is should the moisture content not very low. The leaves should have a little of moisture content, so it can leaf collected by machine.
And how many speeds did you check? Advanced speeds. So have you checked different speeds? And
no,
only one.
No, 3 replication we did, and it is
Replications okay. What is the speed?
What do you mean?
Speed mean you are dragging or moving forward. So how about that? Is it how many for hour or the meters per second or something about the velocity or speed?
It is constant about 0.3 meter per second.
0.3. So only one speed you checked. Why is that?
Yes.
Why is that? Why not other speed?
We have limited. Okay.
You had limited time. Okay. Okay. Thank you. Good stuff. Good job.
Yes, okay. Thank you very much for the research team from the Sultan Qaboos University. And again, thank you very much, Ms. Shata Al-Amir. And then we move to next presentation, design and performance testing of a line sorting machines. It is also from the scientist group from the Sultan Qaboos University. Aisha Al-Hadrami, Mariam Al-Sadi, Anwa Al-Akbari, Hemant Jayasuriya, Saif Al-Adawi, and Moham Al-Belushi. Now, presentation is open.
Hello everyone, my name is Aisha Al-Hadrami and I'm from Sultan Qaboos University,
Today, I will present our team project, which is done by me, Arwa Al-Aghbari and Mariam Saadi. Our project titled Development and Performance Testing of Line Sorting Machine. Let's start with introduction. Sorting is the process of separating fruits and vegetables according to their physical properties, such as texture, color, and size, or sometimes according to their chemical properties, such as pH and other properties. Food sorting is considered one of the main important post-harvest operations. In past, people used manual sorting to sort different types of fruits and vegetables. However, manual sorting method has several and many disadvantages. Our research objectives have two parts. Main objective and specific objectives. The main objective is to design and development of a very simple, low-cost and user-friendly device for line sorting. The second part, specific objectives, including 3 points. The first point, prototype design, development and fabrication. The second point, performance testing, mechanical and ergonomics. And the last point, cost analysis, POQ and break-even analysis. Let's move to the methodology part. This chart shows the overall methodology, starting with design assembly and finishing with performance testing. Our machine assembly including four subsystems: feeding, sorting, rotating, and mainframe. After that, drawing assembly will be. Then after drawing, we select the appropriate materials according to standards. Then fabrication steps to create the first prototype. After that, the performance testing coming, mechanical test, sorting error analysis test, quality of product test, and ergonomic tests. This picture, the first picture, shows the final 3D assembly of the machine, and this picture is the real assembly of our machine. Moving to results and discussion, starting with sorting efficiency test. This table shows the percentage of error, sorting error due to the tested machine slopes or degrees. We have 5 different degrees: 1, 3, 5, 7, and 9. Machine slope with degree 9 here. It shows highly percentage of sorting error. It is 61.33% in box 4, and the lowest percentage of sorting error is in degree 1. In box 1, it is 1.33%. However, the sorting time is found inversely proportional to the sorting error. This chart showing the percentage error of collection boxes at different machine installation, and the error bars. These error bars shows the standard deviation. Moving to the test line thrown out, this table shows the speed in revolution per minute and percentage of number of thrown line out. The degree 9, it shows the highest percentage of number of thrown down. It's average 13, and degree 1 shows the lowest one. It is 2%. Moving to the third test, it is ergonomic performance test. This picture shows the different body regions, and this table shows the estimated scale for each region. The scale is from 1 to 10, from very comfortable to intolerable. After calculating the total, it is 47.7, and getting the average, we get the value 3.2. 3.2 value, it is between very comfortable and some comfortable here, or we can say that our machine, it is some comfortable. Moving to the second test is lifting index, notch lifting index. This table shows the estimated multiples for notch lifting index, horizontal and vertical distance, coupling multiple, and frequency. And using this equation, RWL, referring to recommendation weight limit, to calculate the lifting index. The lifting index value, it should be less than 1. And after we calculated the lifting index value for our machine, it is 0.502, and it is less than 1. It means that our machine in a very sufficiently condition. Moving to cost analysis, this table shows the cost parameters. Here it is break-even analysis and break-even quantity for fixed cost and variable cost, and total for traditional method and machine method. And also it shows the 5 years time for the machine, annual cost for machine method and traditional method. This chart, it shows that the break-even point, it is between 600 for both. After this point, the traditional method increased and highly increased, but machine cost is decreasing. Or we can say it is less than traditional cost. This table shows a specification table, capacity, weight, power requirement, and labor requirement, and so on. Finally, our conclusions is to use this machine. We can use this machine easily by unskilled worker because it is simple mechanism. The break-even point for the machine is 629 kg. Can reach it in 0.32 days. The optimal machine slope could be 1 or 3 degrees when consider both sorting accuracy and time. At degree 1 machine slope, the error percentage of boxes between 1 and 4 shown is 1.33%, 2.67%, 5.33%, and 4% respectively for each box. At degree 1 machine slope, lime thrown out was minimum when we compare it with other angles. We recommend to cover the sharp edge with rubber to avoid bruising damage in lines. Also, we recommend to improve the feeder design to increase the capability for large number of lines. We need, this machine, it needs further testing to optimize the machine angle and speed to find the best outcomes. We can say minimum sorting error, minimum time, and minimum lime thrown out. Also, it can be converted from manual rotation to motor or engine. This is short video clip showing the process. This is some of our references list. Thank you for listening and watching. If you have any questions, we are happy to answer it. Goodbye.
Thank you very much, Ms. Aisha. Actually, it's a very valuable finding, I think. Very valuable, innovative finding that line sorting machines. Really, it addressed, even you evaluated it, economic evaluation, even ergonomic evaluation. that is related with the social acceptability and everything you evaluated. It's very interesting and important findings. Now the presentation is open for the question.
So normally, what is the diameter of the citrus? Diameters or the mass, weight? Hello?
Miss Aisha? She's there, need.
Hello?
It's muted.
Muted, they are not.
I can't see.
Aisha.
Once you muted, this is going down on the list. That is the issue. You can't trace.
Miss Aisha or any other from this research team?
And again, this rotation. So again, so need to know about, have you checked for different speeds or the mechanism of that one? So there are some machines for this kind of selection. They are using some sort of centrifugal forces and all that. So this is interesting.
Yes.
And also we would like to know actually sorting criteria, only diameter or another criteria.
Weight.
Yes. Because angle also used in the
Now Aisha here now. Now we have her. Aisha, can you? Yeah. Yeah. Now she unmuted. Yeah.
Aisha, can you tell that now? Now you are going to sort it out. So how are you going to sort it out? So what is their diameters, or based on the diameters, or if not the mass or the weight? How did you do it? Or what are your specifications? Hello?
Yes, she's there. She's answering but not sounding.
We issue with the microphones.
Yes, she's talking but unable to hear neither.
Could you hear me?
Yes,
yes,
now
yes.
okay, now okay.
Okay, so we sort the limes according to different sizes. Before we fabricate, we bring a group of lines and we measure the diameters, 2 diameters, and then we calculate it and we get the average. That's why we put the sorting according this situation.
And next one is what is the revolutions per minute, RPM, or rotation speeds? Have you checked it for different speeds?
Could you repeat your question again, please? The voice is not clear.
Yeah. How about the speed of the machine, the RPM or whatever? Have you checked it with different speeds?
Yeah, the speed in RPM.
Yeah,
we calculate in each turn, we calculate the time, and also then we calculate the speed.
How was your grading efficiency? Grading efficiency? Or the selecting, grading or sorting efficiency? How was it? Have you checked it?
Yes, we check it. We put one test. It is like a sorting efficiency test. This test, we calculate the percentage of error of optimum angle of limes. We have, as I mentioned, we have 5 angles.
Yeah, for in again now, when you are selecting, sorting it out, now there are different, you cannot find out the same diameters, right? So you have to give a range or the average, right? So maximum and the minimum.
Yes.
So you have done that, right? That physical
Yeah.
characters. Before that, you will check it out. So what is the normal diameter? Is it citrus means, lime or kind of orange? What is this, the type of fruit? Oh, I don't know, fruit or whatever. Hello?
Could you please repeat your question again?
Yeah, now when you are taking that, there are different diameters, right? Not one. So therefore, you can find out the minimum and the maximum, and you can give a range. Okay?
Yes.
So what is the type? This is lime, small one. So what is the average diameter? Average diameter? Is it orange or lime?
Yeah, we put it as a range. In each size, we have minimum and we have minimum and we have maximum in each side.
So what is the grading time? How long does it take to sort it out? Have you checked the time period for the sorting? Different speed.
Yes.
So that means when you are speeding it up, the disk or your speed.
Yeah, when we increase the speed, the time it will be for sorting it will be less. But sometimes the number of thrown lime out it will be more because we turn it quickly, faster, and yeah.
So what is the maximum speed you take?
Sorry again, could you repeat your question?
No. What is your
maximum
speed? What is your maximum speed you checked?
The maximum speed?
Yeah.
It is in angle 9. It is like 20 revolution per minute.
20 RPM, right?
Yeah.
20 RPM. Okay, thank you. Good job.
Thank you.
Thank you very much, Ms. Aisha and the team, research team. It's very inspiring finding. I think you can commercialize it, I think. Now we are moving to next presentation. Design, development and performance testing of a solar powered remote control sluice gate for affluent irrigation. That is also from the research groups from Sultan Qaboos University. The scientists are Ohud Al-Ghathani, Sheka Al-Rashidi, Hemant Jayasuriya, Saif Al-Adawi, and Moham Al-Belushi. I'm very sorry if pronunciation errors are there. Now the presentation is open.
I am Ruhuna Al-Ghadani, student at Sultan Qaboos University in College of Agricultural and Marine Science. I will present our design project, which is design, development, and performance testing of a solar-powered, remote-controlled sluice gate for flag irrigation. It's done by me and my colleagues Sheikh Al-Rashidi. We would like to express our thanks to Dr. Himanatha, Mr. Saif, and Mr. Muhammad for supporting us to complete our design project. In the presentation, I will follow this outline starting by introduction, material and method, then result and analysis, conclusion and recommendation, and finally list of references. In introduction, I will talk about a flag system in Oman, rationale of the project and objectives. A flag system. A flag, as shown in this picture, is a canal system that provides water for farmers and for domestic use. There are many methods used to distribute a flag water, which are traditional sundial and star method, and cycle or rotation, which is known in Oman as Dawaran. Omani farmers still follow the traditional method for distributing a flag water by remove a big stone from the distribution channel. It has many disadvantages, which are it needs more effort to open the distribution channel, and even distribution of water ration at times needs good management and precise timing for each user. Unfortunately, sometimes disputes occur between FedEx users. The main objective of our design is to design, develop, and test the efficiency of environmentally friendly, low-cost solar-powered gate that controls the flow and distribution of a flag water evenly to the farms with the 4 remote controls. And the specific objective is to search for information about a flag system and sluice gate, to design, prototype, and develop it, to evaluate the performance of the prototype using various tests, and to conduct cost, benefit, and break-even analysis. In literature review, we discussed sluice gate type, performance test, and ergonomic test. Moving to materials and methods, the main consideration is to make the process of distributing a flag water simple in terms of the effort and skill required. This figure shows the flow chart of the design methodology. This figure shows the main component of each subsystems in our design, which are power supply subsystem, power transmission subsystem, control subsystems, and sluice gate subsystem. Moving to fabrication of power supply subsystem, where the solar panel and battery were connected to the relay using the connecting wire as shown in this picture. This figure shows the fabrication of sluice gate subsystem, which consists of the frame, adjusted plate, sliding gate, and supporting base, and fabrication of power transmission subsystem, which consists of the motor and sliding mechanism. About fabrication of control subsystem, the motor drive, battery, Bluetooth, and motor were connected to the Arduino, where we use specific code to control the sliding gate. Moving to results and analysis, we will start by assembly drawing of each subsystems as shown in these figures. And these figures show the assembly drawing of whole machine. This table shows specifications of our machines. The whole weight of our machine is 16.42 kilograms, and the maximum power for solar panel is 50 watts. We need only one labor, and for maintenance we need to lubricate, rubber beading, cleaning solar panel. Let's moving to performance test, starting by power drain test, where the ammeter was used to measure the current of the sliding gate during upstroke and downstroke as shown in this table. This chart shows the solar radiation in kilojoule per meter square for 8 hours, and the data was collected by using pyranometer. This table shows the power drain during upstroke and downstroke of the sliding gate, and we conclude that the power drain per day gate movements when using solar panel with the efficiency 20% is 0.0806 watt hour and 0.00672 ampere hour, and the power drain from a 24 ampere hour battery can be negligible, and we can use smaller solar panel. Let's now move to talking about friction force test, where the digital weighing scale was used to find the friction force effect on sliding gate when it is moving up and down in kilogram. The average when it is moving up is 1.78, and when it is moving down is 1.274. These two figures show the force balance when moving the sliding gate up and down, and the power required to move the sliding gate upward is higher than the power required to move sliding gate downward. It is due to the friction force acting on the sliding gate. For ergonomic test, we use the cornell postural disconformed evaluation to test the whole body conformed for the manual method, and we found that the average is 2.9, and we conclude that the manual method is highly risk and uncomfortable method. Also, we did the Cornell evaluation for right hand and left hand test, and we find that the average for right hand is 2.85 and the average for left hand is 2.42, and it is clear that the right hand was more affected during the work than the left hand. Overall, the manual method showed highly discomfort of both hands. The lifting index of the sluice gate was determined by estimating the recommended weight limit and the load weight using the standard noise equation. This table shows the multiplier for the noise equations. After doing the calculation, we find that the lifting index is 1.17, which is greater than 1. That means the manual method is dangerous and unconformed and has high pain and risk for the workers. For break-even analysis, we determine the total fixed cost for the machine and the manual method and total variable cost for both of them. We consider that the lifetime for the machine is 5 years, and we calculate the annual fixed cost for both machine and traditional method and the annual variable cost as shown in this table. This chart shows comparison of the total annual variable and fixed cost for the manual method and sluice gate, and the break-even point is more than 700 liters per year. Is very low because the annual fixed cost of the machine is much higher than the annual fixed cost for the manual, and the rate of the machine is much smaller than the rate of the manual. So the sluice gate will be highly useful machine for a flag system. To conclude, no previous studies was found in solar-powered mobile-operated sluice gate for a flag system. The power requirement is 0.0806 watt-hour to open the sluice gate and close it 2 times per day. The noise lifting index for manual method was 1.17, which is a very unsatisfying condition because it is more than 1. In recommendation, it is recommended to fix a sieve mesh around the sluice gate to block the movement of the plant residual. Also, it is recommended to use a webcam to monitor the flow of water at the entrance of the sluice gate, and to use smaller solar panel, and to use a flow sensor to control the distribution of water to the farms accurately. Now let's see a video of our design project.
Okay, again, close, please.
Some issues in video playing.
Okay, again, close, please.
this is our references that we use in our design project. And thank you for listening.
Thank you very much, Ms. Ohud El Ghadani. Actually, it is very interesting, and even it's a very good invention using renewable energy. Even we can apply it for the rural context, even though there are no national power supplied by the national grid even. Therefore, it is very important. Even that concept is very helpful for our Sri Lankan context also. Now, your presentation is open for the questions.
Now, Gadhani, I have a small question. The system is very interesting and really love to see it. But your system consumes very low amount of energy. It is true. And you are supposing that you will be able to reduce the solar panel as well. Maybe your objective is to reduce the initial cost, capital cost maybe. But what I noticed that the solar panel voltage is 10 volt and the battery is 12 volt. So then we know that principally that the solar panel voltage should be higher than the battery. So are you using some step up mechanism like MPPT charge control or something? How do you do that? Even at the moment, I can't understand that how 10 volt solar panel can charge a 12 volt battery. Hello? I don't know whether she's...
Yes,
yeah.
yes, check. It's old.
Yeah. Yeah.
About the solar panel that we use, the maximum power that can give us, it was 50 watt.
50 watt. It is watt, right? Power, not the voltage.
Yes, yes.
So the electromotive power, I'm talking about electromotive power, the voltage that usually if you want to charge a battery, that your supply voltage should be higher than the battery terminal voltage, right?
Yes.
So then your panel voltage is 10, according to my reference to your presentation. And battery voltage is, terminal voltage is 12, and your solar panel voltage is 10 volts. So then how did you charge the battery? And there are some step-up transformers. I can't see any transformer there, but maybe the SMD systems might be there. And some other, there are potential increase circuits are there. I don't know whether you are using some charge controller like MPPT charge controller or something. Right. If you don't have any information, maybe, yeah. Maybe
About that, we didn't have any information. Actually, the battery was already charged before.
Yeah.
So the solar panel was for recharged to confirm or to make sure that the charge will not finish from the battery. Only like this.
Mm-hmm.
And actually, our design does not consume a lot of power.
Sorry?
Actually, also our design will not consume a lot of power from the battery. So it's already charged.
Mm-hmm.
And the solar panel was to recharge it, to make sure that the charge will not finish.
Mm-hmm. How many panels you used? Only one panel?
Only one panel.
Uh-huh. Okay. Maybe you know. I think the battery capacity may be enough for your proto testing. I think that's why that it does not want that. I did not want that that amount of power to charge by the solar panel. But anyway, that you can search on that. Thank you.
Okay, thank you. Is there any questions from Ms. Ohud? If there are no questions, shall we move to next presentation? Thank you very much, Ms. Ohud and the research team for having such wonderful invention. And next we are moving to next presentation, development of Green Consumer Behavior Index. It's a tool to evaluate the consumer green behavior and sustainable consumption. The research team, PLDU Prematilaka, HAC Priyankar and CM Navaratna. Now presentation is open.
Have a nice day for you all. I'm PLD Udayangani Prematilaka. My research topic is development of Green Consumer Behavior Index, a tool to evaluate the consumer's green behavior and sustainable consumption. This is the presentation content. Let's move to introduction. The Green Consumer Index is meant to encourage sustainable consumption by increasing consumer awareness and providing consumers with point for comparing their own consumption pattern. At present, unsustainable consumption and production lead to inadequate supply and access to the essential goods and services and many more negative consequences. In order to become responsible, sustainable citizen, identification of sustainability indicators are important, but it's quite difficult to evaluate the behavior of the person. Therefore, this index finding will be useful as a tool to evaluate consumers' green consumption behavior and sustainable as a green marketing tool. Objectives. There are 4 objectives, and my major key objective is that to develop an index to evaluate green behavior and sustainable consumption. Methodology. I identified factors that affect on sustainable consumption and green consumer behavior with support of literature survey. After that, I developed the green index, and after that, I conduct survey to test develop index. After data analyzing, finally, I validate this index. Major categories of Green Consumer Behavior Index. Sustainable consumption and production is 12th goal of Sustainable Development Goals that introduced by European Union. According to that, I chose major 4 categories. Those are product selection and purchasing behavior, energy conserving behavior, and household waste management practices of consumer, and food and water consumption behavior. Under each major categories, I identified a number of factors that impact on sustainable consumption and green consumer behavior of the consumer. As well as I supported 2 main theories to develop this index. The first one is theory planned behavior, and second one is the theory of green purchasing behavior. This is the overview of the Green Consumer Behavior Index. According to that, 36% of weight I have given for the energy conserving behavior, and I have given 25% of weight for the food and water consumption behavior, and I have given 17% for the household and waste management for practices. At last, I have given 22% for the product selection and purchasing behavior. These major categories I divided into subcategories. In these subcategories, it included number of behaviors that impact on environment. This is the scale of Green Consumer Behavior Index. According to that, the persons who have taken less than 40 marks considered as the person who having poor green behavior, as well as the person who take more than 80% considered as the person who have outstanding green behavior. Data collection and analysis. The convenient sampling technique was used to select this sample, and the data was collected by interviewing 136 participants using developed semi-structured questionnaire for this study. This is the demographic information of participated consumers, and frequency distribution of income level of the participant can be shown like this. And this is the normal distribution of the index score, and the majority of people have get around 56 marks. Therefore, we can consider that the majority of participants had unsatisfied green behavior. According to the results, there was no association between gender and green consumer behavior of the consumer, and there was no association found between age and green consumer behavior of the consumer, and as same as there was no association between income and green consumer behavior value. But there was an association between education level and green consumer behavior value. We can see that majority of person who have taken outstanding green behavior belongs to high education category. Evaluation of consumer sustainable consumption and green behavior with green consumer behavior index. Let's take one example. Think this person has taken 51% for this index. According to that, this analysis, we can see that this person has taken only 11 marks for the energy conserving behavior and waste management practices. We can say that if we do comparison among achieved and unachieved marks against total score, we can say this person has taken only 11 for that category, but he can achieved total marks for that category is 37.8. Overall, we can say that this person has scored only 30% for the energy conserving behavior category. If we do further analysis, we can say this person has less concern on vehicle purchasing and his transport behavior, and he has he do not concern on environmental friendly buying of environmental friendly packages, as well as he used to do food wasting, and we can say he rarely use the waste items. Validation of the index. For the validation purpose of the index, 30 participants were selected with purposive sampling technique, and we conduct a survey. This is the score distribution of validation sample. According to that also, the majority were unsatisfied green behavior. After that, we were asked about the opinion on green consumer behavior index. The majority responded that their green index value reflects their behavior on sustainable consumption. Let's move to the influence. After that, I studied the influence of crisis on general behavior changes during crisis. The participants were questioned about the general behavior changes in above main criteria. According to that results, we can say the participants' normal behavior on food and water consumption extremely influenced in pandemic situation. This is the conclusion. According to that, the association between education level and green behavior of the index value was found, and high educated consumers' concern on environment and sustainable consumption compared to less educated consumers. According to validation test results, a majority of participants agreed with their GCBI value, which is reflect their green behavior. Finally, I would like to recommend that this green consumer behavior to identify the consumer's green behavior, and to change the identified negative behaviors of the consumer, and to evaluate and to assist consumers, producers, policymakers, and academic in encouraging sustainable consumption behavior. These are my references. Thank you.
Thank you very much, Ms. Prematilaka, regarding your very interesting presentation on green consumer behavior index. And now presentation is open for the questions. Yes, Ms. Prematilaka,
Yes, madam.
is it possible to using that green consumer behavior index by changing some behavioral changes by ourselves, Can we evaluate it individually by ourselves?
Yes, madam, we can do. Just think, we have some negative behaviors, but we want to change that negative behaviors. After we change that negative behaviors, we can do again, use that index, and we can have a score and analysis whether my negative behaviors has improved or not.
Actually, Ms. Premati, like it's that challenge in that people should know about that scorecard regarding different behavioral patterns. If know the people about the kind of scorecard of different green behavior pattern, then we can evaluate by ourselves. No, without knowing that, it is not possible. No.
Madam, I have further have I'm sorry. Further, I have think to develop some that like how it's like when someone click that certain options, then he will can see that his marks for each behaviors.
Yes. Is it possible to publish some kind of values given with different behavioral patterns?
Yes, madam.
If you can even publish those things like scorecard or something like that, then everyone knows what is the value, no? By changing behavior. Though we change some behaviors, but we don't know what is the value given for that, right?
Yes, madam. We can
Without you. That's
we can show obviously we can show give some idea for that consumer to that points that relevant for that certain behaviors.
Yes, it's interesting. Even we can start this one from our university level. Even we can some of the scientists in Sultan Qaboos University also, we can invite them to use these kind of scores, kind of behavioral pattern related to the some changes with scores, and just adapt to the green behavior. Even during the keynote speech also, Professor Hemant Jayasuri also told that though we are moving towards the energy intensive things, but we should everything should be environmental friendly, even it should be sustainable mode, right? That's why it's very important to have such finding. Is there any questions from others? If not, we can conclude the session for morning session.
Thank you, madam. Hope you all had an interesting morning session with the URSAE 2022. And now we will break for the lunch and meet you all at around 1:30 p.m. You can join the symposium by using the same link that you have used previously. See you all at 1:30.
Recording stopped.
to invite Mrs. Chinta Rupasinghe, the chairperson of today's session, to take the lead. Madam, over to you.
Thank you very much, Keertana. Now we are going to start the session number 1, afternoon session. In the session number 1, the first the research topic on development, calibration and validation of a hypothetical cultivar for Sevenagala rain-fed sugarcane plantation with APSIM model. The research scientists are S. Yogeswaran, LMJR Vijayawardena, CM Navaratna, and DABN Amarasekara. Now you can open the presentation.
Today, I'll be presenting my research, development, calibration, and validation of a hypothetical cultivar for Sevenagala rain-fed sugarcane plantation with APSIM. Presentation consists of 8 main segments. Let's move on to them. The necessity of a hypothetical cultivar have been conveyed by many past studies. The concept matters because simulation of the yield of sugarcane plantations in Sri Lanka via crop models may not be effective without a parameterized sugarcane cultivar representing the respective conditions. For plantation managers, their management decisions are based on average yield forecast of the whole plantation. It will not possible without a land which can represent the entire plantation. Therefore, the identified problems were ineffective manual harvest forecast, unavailability of parameterized cultivar, and subsequent unreliable simulations and higher cost of farmer field level yield forecast. Hence, developing a hypothetical cultivar to represent Sevenagala rain-fed sugarcane plantation in APSIM was said to be the main objective. Calibration and validation of this cultivar and the determination of representative lands for the entire plantation were set as specific objectives. Diagram illustrates the sequence of steps followed in the methodology. The APSIM came as a statistically well-performed crop modeling program in 1960s. Variety parameters in the INI file of the APSIM sugar are given in Table 1. Leaf size, thermal time, and green leaf number were used for the simulation. The rain-fed sugarcane plantation of Sevenagala was selected as the study area. The necessary data for APSIM simulations were taken from my external supervisor. It was based on the selected 94 rain-fed sugarcane farm fields as they were selected for replanting in 2018. The sample selection was based on comparative analysis as mentioned in Table 2. Based on 3 cultivar parameters, 27 different treatment combinations were formed. Default INI file of the APSIM sugar was modified with the above 27 treatment combinations. For the development of hypothetical cultivar, paired t-test was performed between actual and simulated yields of 27 cultivars. MAPE values of the non-significant cultivars were found. One sample t-test was performed between simulated yield of SL hypo 17 and plantation average, as this cultivar was found to be with the minimum MAPE value. Some cultivars were found with higher MAPE values despite being near to the median of the plantation average values. So, SL hypo 17 was found to be between 6th and 7th deciles. For the purpose of determining representative lands, one sample t-test was performed between simulated yield of 94 lands and the plantation average yield. Subsequently, the simulated yield of 56 non-significant lands were compared with the deciles of the plantation average values. D value, RMSE value, and percent bias values were calculated for model validation. The common letter shared by 3 levels of means illustrates the non-significance of field size. Thermal time was found to be a significant parameter influencing the yield. Greenleaf number also found to be a significant parameter influencing yield variations. As explained earlier, according to the pair t-test and MAPE values, SL hyper 17 was regarded as the best fit continuum. This had been further proved by one sample t-test that implied no significant difference between simulated yield of SL hyper 17 and the plantation average yield. As noticed before, although some cultivars were near to the median of the plantation average value, because of their higher MAPE values, SL hyper 17 was selected as the hypothetical cultivar. Results of the model validation denoted 65% accuracy. It implied the need of further studies to fine-tune this cultivar parameters. The outcomes of one sample t-test and the comparisons made among simulated yield and the desired of plantation average values assured 18 lands as the most representative lands. The findings of the study concluded the significance of greenleaf number and thermal time. SL hyper 17 as a successful cultivar with 65% accuracy and 18 lands to represent the entire plantation. In order to acquire the higher accuracy level, further studies needed to fine-tune the calibration procedure and the significant parameters. Here are the list of literatures I used for this presentation. Thank you for your patience listening.
Thank you very much, Ms. Yogeswaran. Now presentation is open for discussion. Or any questions or any clarification? Ms. Yogeswaran, did you already observe some hypothetical cultivar which are ready for commercialize for the commercial cultivation of sugarcane?
No, madam. No, any hypothetical cultivars. Because we cannot use the inbuilt cultivars in the APSIM model for model to calculate the yield of the sugarcane plantation in Sri Lanka, because those cultivars represent really the outside countries like Australia and South Africa.
Is it not possible to adapt such hypothetical cultivar under Sri Lankan conditions?
This cultivar we have developed for Sri Lankan conditions, but the inbuilt cultivars in APSIM model we cannot adapt for the Sri Lankan conditions.
Ms. Yogeshan, I have a few questions. So how many cultivar parameters did you select for the study?
Only 3.
Only 3?
Yes.
That means, how do you select? Because there are a number of cultivar specific parameters in the APSIM, I think.
Yes, sir. There are 11 cultivar specific parameters, but we selected these 3 because we cannot really understand what does it means when it comes to the Sri Lankan conditions. Some are little doubtful about how to calculate those values in Sri Lankan conditions. Therefore, we have selected these 3 parameters which are definite. Definitely, we can calculate the values for Sri Lanka.
So did you get the measured value or for the calibration process?
These values were not measured, sir. Those are taken from the literatures.
Did you find any related literature? Because there are a number of literature regarding this study, I think. Because yes. I think radiation use efficiency, transpiration efficiency coefficient like parameters are the most sensitive parameters for the yield variation of sugarcane.
Yes, sir. I think
just a suggestion. Yeah.
Yes, that's why we have got 65% accuracy. Nearly 35
Yeah.
we cannot address by this criteria.
So as a suggestion, you can use some statistical approximation because it is difficult to measure those parameters.
Yes.
So you can consider such statistical approximation like techniques for this kind of calibration in future studies.
Yes.
Thank you.
Thank you, sir.
Okay, thank you, Anushka. And is there any questions or any clarification from Ms. Yogeeswaran and the research team? Okay, if there are no such, then we are moving to next presentation. The topic of next presentation is effect of minimal processing on respiration and ethylene production rate of cucumber. The group of scientists are Aisha Al-Hadrami, Ohud Al-Dhani, and Pankaj Patre and Adel Al-Mahaduri. These are the group of research scientists from Sultan Qaboos University. And I'm very sorry if during the presentation, if I made some mistake during the presentation, during pronouncing your names. Therefore, very sorry. Now you can start the presentation.
Hello everyone. I am Ruhuna Al-Ghadani, student at Sultan Qaboos University in College of Agricultural and Marine Science. Today I will present our project, which is effect of minimal processing on respiration and ethylene production rate of cucumber. It's done by me and my colleague Aisha Al-Hadrami. We would like to express our thanks to Dr. Pankaj and Dr. Adil for helping us all the time we need help. We will start our presentation by giving the definition of minimal processing and the importance of minimal processing. Minimal processing is the practice of light heat treatment and preservation of food products using various ways that create little chinks during processing. Figure 1 shows one example of processed food. The importance of minimal processing are to maintain and deliver the fresh products comfortably without losing their nutritious quality. Also to ensure that the product has an adequate shelf life to allow the customer to distribute it. The objective of our project is to measure the physiological attributes of fresh and minimal processed cucumber. Let's now move to talk about the materials and methods. The volume of the 26 cucumbers was determined, 12 cucumbers were peeled, and 2 cucumbers were placed in each box, and we have 13 boxes. One box with the unpeeled cucumber was placed within a temperature of 22 Celsius. 6 boxes were placed in a refrigerator at 5 degrees Celsius. 3 of these boxes contain peeled cucumber, which known as minimal processed cucumber, and 3 boxes contain unpeeled cucumber, which known as normal cucumber. Other 6 boxes were placed in a refrigerator at 10 degrees Celsius. 3 of these boxes contain peeled cucumber and other contain unpeeled cucumber. The respiration and ethylene production rates were measured for all samples 5 times every 4 days by using respiration gas analyzer and ethylene detector as shown in this figure. Now we will talk about results and discussion. We will start by talking about carbon dioxide respiration rate, and this table shows the carbon dioxide respiration rate during experiment period. NC refers to normal cucumbers, MB refers to minimal processed cucumbers, and all of these measurements are plotted in a graph. This graph shows the respiration rate of cucumber for both normal cucumbers and minimal processed cucumbers during days of storage. For normal cucumbers, at 5 degrees Celsius, the carbon dioxide production rate fluctuates between increases and decreases from day 4 and day 15. The reason behind that cucumbers are shielding sensitive, and the shielding injury developed when we stored the cucumbers at temperature below 10 degrees Celsius for a long period of time. At 10 degrees Celsius, carbon dioxide production rate for 4 days increased and then started to decrease until day 15, and then started to increase again. At 22 degrees Celsius, the production rate of carbon dioxide decreased until day 8, and then it started to increase. For the minimal processed cucumbers, at 10 degrees Celsius, the carbon dioxide production rate decreased until day 15 and then increased. And at 22 degrees Celsius, the carbon dioxide production decreased sharply in the first 4 days, and then it will continue decreasing until day 12, then increased until day 20. Figure 5 shows cucumber stored at 10 degrees Celsius. Because cucumber was built, molds and some drop of water appear on it. Other figure shows cucumber stored at 22 degrees Celsius, where a lot of mold appear on it. The reason behind that at this temperature, the relative humidity is high, and it's become a good environment for microbial growth. Let's now talk about ethylene production rate. This table shows ethylene production rate during experiment period. NC refers to normal cucumbers and MB refers to minimal processed cucumber. This graph shows ethylene production rate of cucumber for both normal cucumbers and minimal processed cucumbers during days of storage. For normal cucumbers, at 5 degrees Celsius, ethylene production remained relatively constant until it reached day 12 and then slightly increased. At 10 degrees Celsius, ethylene production decreased from day 4 to day 8 and then remained constant until day 12. And the reason behind that the cucumbers start to get damaged and lose their shelf life because of long storage period. At 22 degrees Celsius, a dramatic decrease in production of ethylene in the first days and then it's remained constant. For the minimal processed cucumbers at 10 degrees Celsius, a constant rate of ethylene production from day 4 to day 12 for minimal processed cucumber. At 22 degrees Celsius, the production of ethylene continuous decreased until day 12 and then slightly increased. These two figures show cucumbers stored at two different temperatures, at 10 degrees Celsius and 22 degrees Celsius. Shrinking appears in processing cucumbers at 10 degrees Celsius. And for the other, some roots and brown spots appear in the minimal processed cucumbers, and that indicate at this temperature the cucumbers lose their shelf life, and due to the high surface area, the microbial growth will increase and will compete to take ethylene gas. To conclude, minimal processing is an important technique to get good quality food and to increase the shelf life of the food. Also, cucumbers should be stored between 10 to 12 degrees Celsius, and cucumbers are shielding sensitive. So if are kept below 10 degrees Celsius for longer than 2 or 3 days, shielding's harm occurs. Finally, this is some of references that we use in our project. Thank you for listening.
Thank you very much, Ms. Ohud, for doing a wonderful presentation, research findings, explaining. And now presentation is open for questions.
So can I ask some clarification from these authors?
Yes.
Okay. So then just I want to know that this is a very good presentation, and then I want to know that what is the purpose of measuring ethylene concentration? Can you explain? I think
yes, Miss Ohud, she's in the that list, participants list, but mute. Miss Ohud.
I think she is not in online.
She's there in the list. Ohud, and even I think Dr. Pankaj also there.
Aisha also there.
Huh? Yes, Aisha also there. Ni?
Maybe.
Yes, she's now in online.
Okay.
We measure the ethylene because we want to see the effect of that in the minimal processing and how that will affect the quality of our product, which is cucumber.
So what type of statistical method you use for this experimental design? I think did you use any statistical method, layout or design? Because you are just giving just some conclusions, so without giving some statistical things, I think you may have done it.
No, we don't use any statistics.
I think it is better if you use it. It is good. Okay, thank you.
I think maybe there is a part of ongoing study. Maybe that's why they have already presented some of work. Maybe I guess that. I'm curious about that, whether you have done any sterilization in these boxes. So any sort of prevention this the fungal spores or something?
You mean if we use any of sterilization material in that boxes?
Yeah. Sterilization, so how this fungal that spores, and we saw that very much developed fungus body, right? Spores, kind of basidiums in the outer surface of these cucumber.
Yes, the fungi is appear because the boxes is almost closed, and when it's closed, there is like water dropped, like humidity increases. That's why it is the environment for living fungi, having fungi.
Okay, but then
it doesn't mean like when we are not sterilize it or we not, yeah.
And there are some hot water treatment. Hot means warm water treatment for these fungus. So, I'm just commenting that I heard that before processing that they submerge cucumbers. It is about 40 to 45 Celsius of warm water, kind of preventing some these fungal spores. So I'm curious about whether there is a way to prevent it somehow in that way.
I think from my point, there is a way to prevent it. I read one paper that they spray the vegetables. One spray, it is like with no color, and it is edible and not affect very much the the varieties or the features of the vegetables, but it is avoid the fungi. But I'm not sure if it's like it's work or not. In our research, we'll not use it.
Okay, thank you. Thank you very much, Aisha.
Welcome.
Thank you very much, Aisha. Is there any questions from that presentation? If there are no questions, then we can move. Before that, I want to give our heartiest thank for the participants from the Sultan Qaboos University, the students and also even faculties. Professor Hemanta Jayasuri, even still we are staying with that Dr. Pankaj. Actually, we are give our very much kind regards for all of you, and even our sincere thanks for you because you are participating with this event. Actually, it is a kind of enhance the quality of our event even, and even it is globalized. Actually, we can say our undergraduate research symposium is this URSAE 2022. It's a globalized event. Therefore, we will hope to have, if there are any kind of event in your university also, we are very much willing to participate, our students also. Yeah, in the other sense, actually, we hope that next time also, this is annual event. Next time also, your valuable participation. We hope that things. Please stay with us further because we have few more presentations. And now, thank you.
And also, madam, now they are actually having, I heard that they are having exams. Even during the exams, their contribution is greatly appreciated. So,
yes.
Yeah, it added very much meaning to us. So thank you very much.
Yes. Thank you very much. That is from sound. You can hear from even our coordinator of this year's symposium, URSAE 2022. Thank you very much again. And now we are moving to the next presentation. I think Dr. Jinendra, we can get the abstract and the things are circulated for them, no? Even certificate.
Yes, we will provide them the certificate, participation of certificate. Yeah.
Okay.
For the proceedings, we will provide. Yeah.
And next we are moving to next presentation, experimental study on optimization of air movement concerning the openings in a tropical building layout. The scientists are SDP Samyada Vasudha Prabodhini, Abhiratna, and R.U. Alvatura, and Jiva Jayasinghe. Now presentation is open.
Good morning, I'm Parami Samyada. My research topic is experimental study on optimization of air movements with respect to the openings in a tropical building layout. This is the presentation outlines. And this is the introduction. The building sector is the biggest single contributor to the world energy consumption. Buildings consume around 40% of global energy and contribute more than 30% of greenhouse gas emission. That energy consumption is highly used for the indoor thermal comfort of buildings. Heating, ventilation, and air conditioning systems account for roughly 68% of total energy consumption in commercial and residential buildings. Natural ventilation can be used as the best alternative for the mechanical ventilation throughout the world. Natural ventilation can be identified as the process which fresh air introduced into indoor spaces without using any mechanical system. Natural ventilation inside buildings can be divided into two categories. They are air pressure ventilation and stack effect ventilation. Cross ventilation is more effective than stack ventilation in tropical regions because there is no substantial differences in temperature between the indoor and outdoor environments. The effectiveness of natural ventilation is determined by the local microclimates as well as structure itself, such as orientation, number of windows, openings, and sizes and locations. The thermal performance of the building envelope is significantly influenced by windows and doors. Windows can also have a big impact on how people utilize the building, how productive they are, and how comfortable they are. This is the problem statement of this research. Indoor overheating is one of the biggest problems in the tropical buildings. People cannot manage it without cooling systems. Active cooling is not healthy for the environment, as well as exposing them for a longer period of time can badly affect for the human health. People should pay their attention on passive cooling systems and natural ventilation. So it is important to consider about opening arrangement for better cooling. These are the objectives of this study. First one is investigate the ventilation patterns of indoor environment. Second one is to identify the indoor air movements with respect to the openings. This is the methodology of this study. Comprehensive literature has been done and find out the natural ventilation techniques. Then find out a typical house plan of Sri Lanka. After that, scale down its dimensions and create it in a glass chamber. Then selected one room and mark some points in the ground like this. Then enter the smoke in front of the building from main door, and take videos while smoke come and cover the marks, and take the time from it. Then change the openings locations and find the impact of the openings. This is the first step of methodology, comprehensive literature review. Cross ventilation, single side ventilation, stack ventilation, and mixed strategy ventilation are four basic natural ventilation techniques. Cross ventilation and stack ventilation are both unidirectional techniques that require at least two openings, an inlet and outlet. Cross ventilation, on the other hand, is a horizontal process, whereas stack ventilation is a vertical process. Openings are primarily positioned on two sides of a building in cross ventilation, and the pressure differential between these two openings create indoor airflow that migrate from higher to lower pressure. The temperature differential between the entrance and outlet causes airflow in stack ventilation, which is a thermal buoyancy-driven approach. Because of its lower density, warm air rises and is replaced by cooler air from outside. Single-side ventilation refers to units or apartment having only one or two openings on one side. Mixed strategy ventilation use one or two or more techniques of this. This is the cross ventilation, this is the stack ventilation, and this is single side ventilation, and this is the mixed strategy ventilation technique. This is the house plan of Sri Lanka, typical house plan of Sri Lanka. This is found from earlier research. Then scale down its dimension. This is the three main door location, three room door locations, and three room window locations. This is how glass chamber was prepared. After preparing the glass chamber, cover the edges and prevent the leakages by using tapes. And selected one room and mark some points in the ground. There are 9 points. This is how chamber was prepared for testing. This is how smoke cover the mark points. This is the results and discussion part of my research. According to the objective 1, by the comprehensive literature review, cross-ventilation was identified as the airflow pattern mainly happened horizontally in building indoor environment. After the study, glass chamber arrangement was designed to check the horizontal airflow in building interior. According to the objective 2, it has been studied 27 openings, doors and windows arrangement, and one arrangement was included with main door, room door, one window location. 3 locations were considered for each wall as 3 main door, X1, X2, X3 location, and room door Y1, Y2, Y3 locations, and windows Z1, Z2, and Z3 locations. This is the graphical representation of my results. Conclusion, according to the objective 1, cross-ventilation is mainly happen due to more than one opening when considering horizontal air movements caused by wind. According to the objective 2, fourth arrangement with code X1, Y2 and Y2 Z2 shows the minimum time to cover the all points, and that means this arrangement is suitable for good ventilation for wall room. These are my references, and thank you.
Thank you very much, Ms. Samida. The presentation is open for discussion.
Yes, I have one thing. You scale down the actual system into dimension by length, right?
Yes, sir.
So, so then that the aerodynamic principles, can you just simply scale down? So by volume or dimension. These equations are, I don't think that they are directly with did you refer the aerodynamics principles?
Yes, sir.
So because so what is the scale actual system to this one by volume?
1 foot represented by 1 inch.
1 foot by 1 inch. Yeah. So yeah, very. By volume, how did you calculate the by volume? How it was?
No, sir.
That is my question. That I'm curious about that whether it is. Did you do the simulation?
No, sir.
No.
Any other question from Samyada? Okay, if there are no questions, we can move to next presentation. Thank you, Samyada and the team. And
thank you, madam.
Physico-chemical characterization and GIS-based assessment of groundwater quality in Tiramara River Basin, Southern Province, Sri Lanka. The group of scientists are Odi IP Disanayaka, PANT Pereira and GY Jayasinghe. Now presentation can open.
Welcome all. I'm going to present my undergraduate research presentation. My research topic is physicochemical characterization and GIS-based assessment of groundwater quality in Kirama-Ara River Basin, southern province, Sri Lanka. These are the outline of my presentation. First of all, I would like to give some brief introduction about my research area. My research area is about groundwater quality. Groundwater is one of the foremost precious source of beverage while employed in several elements of the planet. Groundwater quality refers to the state of water that is located beneath the Earth's surface. It is used human consumption like domestic, agriculture, and industrial activities. All living beings, ecological systems, production, and economic progress depend on the vital resources of water. Due to the heavy usage and other anthropogenic and natural activities, most of the water resources are under pressure. Therefore, fresh and pure drinking water availability is diminishing and is one of the most pressing issues of the contemporary world. When talking about the groundwater geochemistry, both natural and anthropogenic activities determine the geochemistry of groundwater. pH, total dissolved solid, electrical conductivity, alkalinity, chloride, sulfate, nitrate, phosphate, calcium, magnesium, sodium, and potassium are the major physicochemical characteristics that determine the geochemistry of groundwater. Due to the consumption of contaminated poor quality drinking water, most of the human health problems can occur, such as dental and skeletal health problems, skin cancer, and also the CKDU. Let's note the problem statement. Assessment of groundwater quality for various physicochemical characteristics are more important to ensure the groundwater quality, to ensure the human health, to stabilize the socio-economic vulnerability, and to develop the groundwater resources for the future demand. Most of the groundwater quality evaluation projects use water quality index methods to measuring the extent of water contamination, as well as they use geographic information systems to collecting, categorizing, displaying groundwater geographical data, and making decisions based on the data. Therefore, the proper and quick identification of the groundwater quality to mitigating the human health vulnerability due to drinking water quality is essential for adapting safety precautions and related to the current health problem. These are the objectives of my study. First one is to determine the water quality changes and geochemical characteristics of groundwater, and second one is to assess the non-carcinogenic health risk and develop water quality index for groundwater, and third one is to develop a spatial distribution map for groundwater physicochemical parameters in Kirama-Ara River Basin, Madara, Sri Lanka. Let's move to material and methodology part. This is the conceptual framework of my research, and then selection of study area. As my study area, I have selected Kirama-Ara River Basin, southern province, Madara, Sri Lanka. Using Google Earth Pro, I have extracted my study area and it was divided into 1 by 1 square kilometer grids using ArcGIS 10.8 software. Extraction point of this grid used as my sample location. In this slide, you can see my sample locations and the study area map. Overview of the location and its land use. The case study region encompasses 17 square kilometer and it includes 12 Gramanidari divisions. In the study region, paddy cultivation and silver cultivation can be seen as main agricultural activities. Hydrology and groundwater scenario. Groundwater is obtained mainly from in this area from the metamorphic part of aquifers or saprolite developed on metamorphic rocks. In-situ monitoring process and laboratory analysis. After the collection of water sample, all the water samples were chemically and physically analyzed for several physicochemical parameters in the laboratory. Table 1 shows the standard method and instrument for chemical analysis. Development of drinking water quality index. Combining the collected data from the laboratory analysis and WHO standard values, drinking water quality indexes were calculated for all the water samples. In this slide shows the step for developing drinking water quality index, and these three equations were used to calculate the drinking water quality index. Geochemical characterization of groundwater. For the geochemical characterization of groundwater, I have used pipe plots and Gibbs plot. Pipe plots were used to determine the hydrochemical type and phases of groundwater sample, and Gibbs plot were used to determine the groundwater chemistry controlling factors. Human health risk assessment. Health risk due to non-carcinogenic element in different gender and age group was determined by using hazard quotation, considering the oral or ingestion pathway of drinking water. These two equations were used to calculate the chronic daily intake and hazard quotation. According to the USEPA's recommendation, the limit of hazard quotation is 1. If the hazard quotation is greater than 1 mean, pose a substantial health risk due to the specific element. Development is partial distribution map. Using the laboratory analysis data, I have developed groundwater quality partial distribution map for all the physicochemical parameters and as well as drinking water quality indexes. For this, I have used ArcMap 10.8 mapping software. Then move the result and discussion. Part of my study. In this slide, I have mentioned descriptive status of the water quality parameters of the study area. According to that result, 50% of the samples are not in the permissible level for pH, and 6.25% of samples were not in the permissible level for nitrate, and 12.5% of samples were not in the permissible level for phosphate. In this slide, I have mentioned the correlation coefficient matrix for all physicochemical parameters. According to the result, nitrate exhibit strongly positive correlation with chloride, phosphate, potassium, and sodium. Calcium exhibit strongly positive correlation with chloride, nitrate, and sulfate. Sodium and potassium exhibit strongly positive correlation with chloride, nitrate, and phosphate. Development of groundwater quality index. Using the laboratory analysis data, I have developed groundwater quality index for all the sampling location. According to the result, 25% of samples are in the excellent water category level, and 62.5% of samples were in the good water category level, and also 6.25% of samples were in the poor and very poor water category level. In this slide shows the Pearson correlation of all the water quality parameters with the drinking water quality index. According to the result, most significant correlation was recorded between chloride and the drinking water quality index. In this slide I have shown the spatial distribution for drinking water quality indexes in the Kiramara River Basin. According to this pattern, G7 and G9 area has excellent water, and G8 area has poor water, and this extreme area has very poor water. Geochemical characterization of groundwater. For the geochemical characterization of groundwater, I have used a pipe diagram. According to this diagram, the cations in the water samples belong to the calcium type with no dominant type, whereas the anions belong to the chloride type with no dominant type. Overall, the majority of the water sample were assigned to zone 1, 4, 5, which represent the calcium magnesium bicarbonate phase, mixed calcium magnesium chloride phase, and the calcium chloride phase respectively. Using the calculated Gibbs ratio, I have drawn the Gibbs plot 1 and Gibbs plot 2. According to these plots, all of the sampling sites were in the middle of both cations and anion base plots, representing the rock dominance of water rock interaction category. According to the findings, rock weathering is a major factor in controlling the ionic composition and chemistry of groundwater in the study area. Human health risk assessment. According to this graph, 50% of the sample having greater than 1 hazard quotation for adults, and 81.25% of samples having greater than 1 hazard quotation for the child. Development of spatial distribution maps. Using the laboratory analysis data, I have developed a spatial distribution map for all the physicochemical parameters. In this slide shows the pH, EC, and total dissolved solute spatial distribution maps. According to these maps, this red color area shows the higher concentration areas for these physicochemical parameters. This slide shows the chloride, nitrate, and phosphate spatial distribution maps. And this slide shows the calcium, potassium, and sodium spatial distribution maps. And also this slide shows the magnesium and sulfate spatial distribution maps. When considering the magnesium spatial distribution maps, in the study region, magnesium concentration is higher than the other physicochemical parameters. According to the result I obtained, I have made some conclusion for my research. First one is the mean concentration of all groundwater quality parameters indicated that except for pH, nitrate, and phosphate, all other water quality parameters are within the maximum permissible limit prescribed for drinking water. 87.5% of groundwater samples are suitable for drinking, and 12.5% of samples are not suitable for drinking in this study area. Poor and unfit water for human consumption is mostly concentrated in the Pahalavitiya, the East GN division, which are very closer to the Kilamara River. These are the references for my study, and thank you all.
Thank you very much, Mr. Disanayake. Now, presentation is open for questions.
Hello, can you hear me?
Yes,
Yes, Mr. Disanayake, I have one question. So is there any specific reason why did you select that study area?
So yes, since according to the peoples living in this area, they said that there is a problem. Their drinking water in the mainly in the domestic wells. Because of I select this area for my study.
And also, what sort of challenges did you face while doing the sampling or your research project? What are the challenges that you faced?
Challenges, sir, I have faced some difficulties collecting water samples, and also some of the limitation of some of the resources. I have faced some difficulties checking some of the parameters like nitrate, phosphate.
Okay, that's all. Thank you.
So, Anthony, now just you are taking water sample and mapping and displaying, so having analysis. So, do you think that how did you standardize these different wells? Because so different, so that if they say that they are having difficulties in accessing drinking water, that maybe you have to think about their is there all the wells with that water with this issue?
No, sir.
No,
some of the people say that there's a problem their wells, and also also since first year I'm in my boarding place, there is a problem in the water in the well. Therefore I selected this area, and this area having lot of agricultural activities, paddy cultivation, cinnamon cultivation, and other. And also I think there is
and did you study about the soil and the layer of the last layer of in the because some wells are maybe laid with this cement, but some of them are exposed to the walls will not be laid, right? Layering. And sometimes some will
sorry sir, I can't.
So sometimes I need to know that the water level in the well, the distance from the ground surface. So that will also affect, right?
Yes, sir.
And the soil type will affect. So
yes, sir.
I think if you are going to compare their characteristic between different wells, that you have to consider these factors.
Yes, sir. I have considered the water depth and the diameter, and I have measured all the parameters in these wells, and I have made some correlation with the physicochemical parameters and the depth and the diameter.
And also depth is one physical parameter, but the depth will cause to have different layers, different types of soil, right? So if this is the same, almost same area, the soil patterns would be almost same in different layers. But if you reach deep down to the bedrock, that those wells will have different qualities of water. So therefore, I think you better focus your results and comparison with this. And have you found any relationship with the quality of water?
No, sir. You mean depth and the relationship in depth and the water quality parameters?
I mean that if you have, let's say, the five well that you found it with 50 meters, the 50 feet, and then five other with 10 or 20, like, then you can check that whether those two wells are having different and consistency in all the five wells in deep down 50 feet will have same quality, or whether the other having a different one.
No, sir. Actually, I have selected the wells with depth between 20 to 30 feet nearly. Therefore, I couldn't get the relationship between the depth and the physicochemical parameters.
Okay. That's no.
Okay, thank you, Dr. Jinendra. And even thank you very much, Mr. Disanayak and the team. And now we are moving to next presentation, next research topic on selecting best grass type for building integrated vegetation system based on thermal insulation capacity. The scientists are Sansarani, HD Sansarani, KG NH Veerasinghe, RU Halwatara, and GY Jayasinghe. Now presentation is over.
Have a nice day all. My research topic is selecting best grass type for building integrated vegetation systems based on thermal insulation capacity. These are research outlines. Introduction. Sri Lanka is located near the equator, so it receives significant amount of solar radiation across all geographical area. So it has a tropical climate with higher temperature, increased urban heat island effect, heat stress, building sick syndrome, and premature mortality are serious environmental and health problems because of overheating of buildings. This figure shows urban heat island profile through rural and urban areas. Thermal insulation capacity is ability to insulating against transmission of heat. Thermal comfort created by urban heating is defined as the condition of mind that expresses satisfaction with the thermal environment. Plants with higher thermal insulation capacity more effective at providing thermal comfort. Nowadays, tendency for building integrated vegetation systems are very high. Building integrated vegetation systems include green roofs and vertical greening systems on both exterior facades and interior walls. It has the capability of scattering, reflecting, and absorbing light. Their performances are mitigation urban heat island effect, temperature control, increase biodiversity, and improve the energy efficiency of buildings. Vegetation is one of the significant components of green roofs as it enhances the system's capacity to provide many benefits. Trees, climbers, creepers, shrubs, herbs, and grasses used as vegetative types. Growing grass is identified to be one of the most effective ways of achieving greenery over buildings to gain additional benefits such as reduction of indoor temperature. Problem statement. There are so many studies with common indoor and outdoor plants associated with buildings, but the capacity of different grass types was not scientifically investigated. Therefore, need to select the best thermal insulation capacity of different grass types from selected grass varieties in Sri Lanka. Objectives of the study are
to look into the thermal insulation potential of a few different grass kinds that are accessible in Sri Lanka and to research into the appropriate grass type that may be suggested as one of the best building integrated vegetation types, materials and methodology. For that experiment, we used 1 cubic foot wooden boxes and also used 2.5 centimeter thickness polystyrene to cover bottom and side walls of the boxes to prevent heat transfer through the exterior and interior. And also, we use potting media. At this, we used topsoil, compost, and coir dust in 2:1 ratio. Grass species selected based on literature review, physical characteristics, and ability to survive in extreme weather conditions. These figures show my cultivated grass species. 2 replicates used for each grass species. Watering was done 3 times per week and organic fertilizer applied 1 times per month. Temperature measurement was done at 10 centimeter depth level of each boxes. Temperature monitoring was done at the moment of the boxes are fully covered with the plant. Cool day temperature recorded for each grass species. MIDI data logger recorded the temperature at every 5 minutes and finally got hourly accumulated temperature. Result and discussion. Temperature monitoring at 10 centimeter depth level. Vegetarian species show higher temperature at midnight and lower temperature at midday than air temperature. Illusion species show higher temperature at midnight and lower temperature at midday than air temperature. Ceteria species showed higher temperature at midnight and lower temperature at midday than air temperature. Another species showed lower temperature at midnight and midday than air temperature. Arthraxine species showed higher temperature at midnight and lower temperature at midday than air temperature. Cypress species showed higher temperature at midnight and lower temperature at midday than air temperature. Axonopus species showed higher temperature at midnight and lower temperature at midday than air temperature. Jancus species showed higher temperature at midnight and lower temperature at midday than air temperature, but the temperature reduction is very low. Controller 1 showed higher temperature at midday and lower temperature at midnight than air temperature, but temperature reduction is very low. We used box with only potting media as controller. Analyzing thermal insulation capacity of the grasses. For all grass species, calculated the temperature reduction from surface to 10 centimeter depth of soil. At this, Victoria species showed full day temperature reduction, but amount of temperature reduction is low. It has low thermal insulation capacity. Illusion species show a temperature reduction at night. It has low thermal insulation capacity. Cynodon species show better temperature reduction. No obvious increase in temperature even at midday because the plant covers the large area. Therefore, soil less contact with the soil. Soil less contact with the heat. Therefore, it has better capacity of thermal insulation. Ceteria species show lower temperature reduction at midday and midnight. Therefore, it has lower thermal insulation capacity. Arthraxine species showed increase in temperature at night. Therefore, it has lower thermal insulation ability. Cypress species showed temperature increase at night time. Therefore, it has lower insulation capacity. Axolotlus species showed low temperature reduction at cool day. Therefore, it has low thermal insulation capacity. Juncus species showed increase in temperature at night, and also it has lower temperature reduction. Therefore, it has poor insulation capacity. Control 1 showed lowest temperature reduction at midday and also increase in temperature at midnight. Conclusion: grass-covered soil has a higher thermal insulation capacity than bare soil. When compared to other plants, Cyanodon species had the best thermal insulation capacity. Automaton species showed better result next to the Cyanodon species. The Setaria species has the poorer ability for thermal insulation than Automaton species. Digitaria, Axonopus, Cyperus, and Eleusine species are less appropriate as construction materials for integrated vegetation systems because they are low thermal insulation ability. The least effective grass species in insulating against heat was Juncus species. The best form of building integrated vegetation was finally recommended to be Cyanodon dactylon. Those are my differences. Thank you for your attention.
Thank you very much, Ms. Sansarani. Now presentation is open for questions.
Sansarani, did you measure soil temperature?
Yes, sir.
Soil temperature. So
10 centimeter below from the soil surface.
How many times you irrigate? How about the irrigation interval?
3 times per week, sir.
3 times
Monday,
per week.
Wednesday, and Friday.
So the soils, how about the texture of the soil? That I mean that whether they are moist and sufficiently. Did you provide water adequately?
Yes, sir. 3 times per week, apply water for all plants.
Then in actual conditions, so how do you apply this in the real environment? Are you going to establish this in rooftop, or where will you be placing this?
Roof slab.
Roof slabs. Is that because of, so if we can go back and see the vegetation, then we can understand a little bit. But anyway, because of this video, and I'm curious about whether this is because of the shading effect or something else. What do you think? Is that because of shading and having high shade environment will have low temperature or something other biochemical impact of plant or whatever kind of reason?
That experiment was done in open area with higher temperature, sir.
Then shading, is that the shading or the variety of that biochemical kind of species influence? Or how can you distinguish that? Whether it is because of the shading, so about the canopy structure.
For thermal insulation.
Yeah.
Thermal insulation considered as a layers.
So thermal insulation, you can put some, you don't need to maintain a grass. You can use something as a mulch. That is the case. That is, but so then you don't need to talk about different varieties and their influence. If it is shading, otherwise, because the thing is that now you know that water is with very high specific heat. So 1 kilograms you need 4,200 joules. So therefore, with that, I'm curious about that, whether this effect based on special type of the plant variety has impact or the shading impact. And I'm curious about that. Just for my comment.
Okay, Sansari, these are food for thought. So for you, your future direction of your research, right?
Okay.
Now, thank you, Ms. Ansarani. Now we are moving to next presentation. Smart monitoring and control of nutrient status in NFT hydroponics by using DFR 0300 development board by scientists are BVD Mihiran and BMS Dinendra.
Hello everyone, I am David Mihiran from the Department of Agricultural Engineering. Today I am going to present on smart monitoring and control of nutrient status in NFT hydroponics by using DFR 300 development board. Let's move to the presentation. Outline. Introduction, problem statement, objectives, materials and methodology, result and discussion, conclusion and references. Introduction. Hydroponics stands for the hydro, water and the phonos for the work in Greek words. Hydroponics proved to be providing high yield as well as high nutritional value than conventional. The hydroponic system allows plant to share the same nutrients. In problem statement, NFT hydroponics is a very effective cultivation method, but the potential for the omission should be minimized. This is because of the roots of the plants are directly submerged in the nutrient solution. If the nutrient level is not optimal, nutrient precipitation or depletion can be occur. It is badly affect on the plant growth. The automated and smart monitoring are currently in demand and an essential role. However, existing systems in the field are either integrated to large scale and no system have been developed for local conditions. The rapidly development of low-cost development platform are invaded the market have made increase in competition with the high-profile standard industrial scale system. This picture you can see how popular custom assemble system and how industrial standard control system. In a popular Arduino platform, data is transmitted over long distances and farmers can view data from the long distances. The open source application programming interface for storing and retrieving data is stored in the cloud server and the monitored data through the smartphone. However, the accuracy of precipitation of such custom assembled systems are to be tested and verified before the practical use. The objective of the study. The main objective of the study is the development of smart nutrient monitoring and control system for the NFT hydroponics. The specific objectives are: first one is the development of microcontroller-based nutrient monitoring and control unit for the NFT hydroponics. Second one is the development of smart IoT mobile-based communication system for the easy operation of the system. And third one is the performance assessment of signal transmission and easy monitoring with custom assembled system. The methodology like this and based on the development microcontroller-based nutrient monitoring control system and the smart IoT mobile-based communication system and the NFT hydroponic system and the performance assessment. The first one is the development of microcontroller-based nutrient monitoring and control system. The first step is the hardware development. For the hardware development, we use the analog electrical conductivity sensor, DFR 300 development board, Node MCU controller, and the ESP28266 Wi-Fi module. The hardware development diagram like this. This picture shows how Node MCU controller board connected with the other components. The second step is the software development. For the software development, we use the Arduino platform for the develop the microcontroller sensory program, and the data which store in the Firebase real-time database. And the construction of the hydroponic system, like 3 rows, 5 plants, 15 plants for the row, and closed and circular system, and the Albert solution for the plant growth medium. They're considering 3 growth stage, like first stage, second stage, and the third stage. And the data observation with the 2 premises in the protected house and the department premises. The protected house implement the hydroponic system and custom assembled sensoring unit, and the data can retrieve and observe with the department premises to the cloud data observation. Every day at 8 to 4 p.m. data observed and collected. And the continuous recording data 10 minutes before and after measurement. And obtain the data for each row at the set intervals with the systematic sensoring data in the 3 rows in the cyclically. One sensoring time approximately 3 to 4 minutes. The picture shows how a sensor probe included and the sensoring unit set. The reference data recording was done with the HANA portable EC meter with the same intervals and the same nutrients solutions. Then the video shows how data stored in the cloud base. The data sensor with the EC sensor, and that data stored in the Firebase database on time. And second step is the development of smart IoT mobile-based communication system for each operation in the system. That picture shows how mobile app interfaces developed. The login user interface, sign up user interface, and the dashboard in the optimal and non-optimal conditions. The mobile application development I use the Android Studio platform with the Java and XML language with the 3 main activities. And this video shows how mobile app works. With the firstly, user can log in with their email and password, and after that they can retrieve the data. First login, they want to create the new account with the mobile app. Result and discussion. First one is the sensor reliability. EC measurement through the DFR 300 low-cost sensor module was with high standard deviation, and the readings were largely deviated from the EC meter. This table shows how deviated data from the standard EC meter and the sensor reading. The error bar chart, which shows the how data deviated from the EC and sensor data. The raw data was obtained through the 300 development environment was significantly different from the reading. Then accuracy improvement by the normalizing the data information. Normalization was done with the Pyroid software. After using Pyroid software, we can use the EC and sensory data from our users. Then we done the paired t-test for the data analysis, and that is the results. And therefore, there has no significant difference between standard meter reading reading and sensor reading after data normalization. The wireless, second one is the wireless data communication. In the wireless communication, there has no significant difference between taking place through and the monitoring phase. Although the accuracy varies through the use of low-cost sensors, the accuracy is done can be obtained by the transforming data by using standard DC meter. It is therefore suitable for large-scale hydroponic subsystem can use with many sensors and one standard DC meter. This is the cost-effective method. Conclusion. Sensor data and standard DC meter data, no significant difference after data normalization. There has no significant difference and no noise adding during wire-based data communication. With the database update, the significant difference that occurs when monitoring through the mobile application is minimal. According to this text, sensor accuracy can be obtained from high accuracy can be achieved by using several sensors in parallel with on standard DC meter. This is my references and thank you all.
Thank you very much, Mr. Meerang. It's a very interesting presentation. Even it's a kind of a smart agriculture, smart farming technology. We can address to precision farming as a precision farming application. It's very interesting. And now the presentation is open for questions.
Right. It seems that you have developed a new, the system to monitor the water, environmental parameters in the hydroponic, no?
Yes, yes, sir.
Yeah, you evaluated only the EC, right?
Yes, sir. EC.
EC only. So
in solution.
Yeah, in your solution, you can control through the mobile, no?
Yes, sir.
How many parameters in your system? How many extra parameters can be included? Maybe pH or some other things can we do? The temperature and RH and so on. Also, it's possible.
Yes, sir, possible. But in the situation, I cannot to find like that sensors in the local market. Then I cannot develop for that parameters.
If it is sensors are available, you can do it.
Yes, sir.
Your system is.
I try to add the pH also, but it cannot be done with the no sensors in the local market.
How about temperature?
Temperature, no huge difference, sir, but we can use DHT11 sensor. We can also detect the temperature also.
So, for example, if you have this all these sensors normally in the greenhouse, I think it's better to control RH, pH, and the temperature, and EC, and so on in the medium as well as in environment. So, if you, in your system, if you include all these things, the cost would be how much?
Approximate. I think it can be developed under 50,000 rupees.
Your system. Are there any, the idea to do, improve your system to as a commercial level? What about that progress?
I think for the commercial level, we can use many parameters and pH, RH, and with many various controlling fields we can use.
Okay, thank you.
Okay, then I think another question is raised from Ms. Sunichiro Kuroki. Yes, sir, please.
Madam,
Thank you very much for your presentation.
I'm from Kobe University. And
Yes, sir.
thank
Welcome,
you
sir.
very much.
Welcome, sir, to URSAE 2022.
Thank you. My question is very simple. Did you make only one prototype? I'm afraid that you compare the commercial one and your development, and you can find a compensation method to the accuracy modification. But if you can make one prototype, how about second one or third one? How do you compensate each the prototypes?
Yeah, good question.
That we can use the many sensors with the same mobile app. We can use the same parameters. We can retrieve the all data in the same mobile applications.
Okay, so you can develop the multi-ways communication systems, right?
Yes, sir.
Communication. Dumidu, don't you think that you need a multiplexing or something like switching between different sensors and with the main board? One main board, or has Arduino provided you access to various many number of sensors as together?
Yes, in Node MCU board, we can use many sensors in the same Node MCU board. But we can use only one sensor for the experiment.
Iran, is it possible to use for nutrients, kind of nitrogen in PK like that, sensors using to control that one?
Yes, madam. In the market, there has sensors for the each various nutrients like NPK levels, but they are very expensive. When we have that one, we can develop the system for that nutrient levels also.
Okay.
Sensei, raise your continue, and I don't know whether Dumidu has given you a reasonable answer.
Yes, I think so. If you develop more, I mean, there's some other question ask that. Yes, Professor Wijutsuga, it's difficult to raise for me, but if you develop for the commercial use or some the large scale use, you should control the many sensors. Even you only measure the electric conductivity, you have to put the 10 or 20 sensors in the factory field. So you can handle somehow to control them. Okay, thank you very much.
Yeah. Yes. Thank you very much for your input, Kuraka Sensei.
Yes, sir. Yes, thank you very much your inputs for developing the experimental concept of Mr. Dumidu. And thank you very much, Dumidu. And
thank you, madam.
Yes, now we are moving to next presentation. The emission pattern.
Audience, madam, shall we just introduce Professor Kuroki that he is going to be one of the keynote speaker.
Yes, please, Dr. Jinendra, please.
Yeah, no, I think just I want to mention that the audience that he will, yeah, valuable keynote speaker in the third day. Yeah, and innovative technologies in agriculture and engineering. So we are pleased to have you in the third day as a keynote speaker, Professor Sensei.
Yes, sir. So you are welcome, warmly welcome for our URSAE 2022 for third session as a keynote speaker. Thank you very much for accepting our invitation, sir.
Thank you very much.
Next, can we move to next presentation? Yes, next presentation is in the topic 1, the emission pattern and source contribution of air pollutant from open burning household waste. The group of scientists are J.R. Mudiappa, G.Y. Jayasinghe, R.U. Halwatura, K.G.N.H. Veerasinghe. Now presentation is open.
Good afternoon to all of you. My undergraduate research is focused on the emission pattern and source contribution of
air pollutants from open burning of household waste. Globally, we produce 1 to 2 billion metric tons of household waste annually, with high-income countries generating an outsized amount compared to their population. Most common waste management practices are incineration, recycling, composting, sanitary landfilling, biological reprocessing, open burning, etc. According to 2018 World Bank's What a Waste 2.0 report, 33% of global household waste ends up openly dumped. That is, 1/3 of the global waste, which creates major waste management issues. Less than 20% of world's trash is recycled or composted. In developing countries, waste separation and collection is not practiced more often because these countries have less capabilities to manage proper waste collection, separation, and disposal. Therefore, open burning is practiced more commonly because it is the easiest, by far the cheapest, most sanitary means of volume reduction method. In Sri Lanka, open burning of household waste is mostly practiced in suburban and rural areas. Carbon dioxide, carbon monoxide, methane, sulfur dioxide, particulate matter, polycyclic aromatic hydrocarbons, oxides of nitrogen, volatile organic compounds are the major gases that emit from burning of household waste. These gases exposed at certain levels can create major health impacts to humans and to the environment. Respiratory diseases, skin and lung cancers are the most common long-term health impacts due to inhale of this plume and dust. The problem statement is, studies have found related to large-scale open burning practices and their effects in countries like China, India, Japan, Iraq, etc. But no any research found about the emission pattern of household waste open burning done in Sri Lanka. Therefore, the studies mainly focuses on identifying the levels and the pattern of pollutant gases and particulate matter that emit when household waste is openly burned. The objective of this study is to measure the level of gases emitted from open burning of common household waste and to identify the source contribution of air pollutants from open burning of common household waste in Sri Lanka. This is the methodology I followed to conduct my research. The materials are used to measure carbon dioxide, particulate matter 2.5, and volatile organic compounds. Readings were taken at 2.5 meter, 5 meter, and 7.5 meter horizontal distances from the burning point, and 1 meter to 9 meter heights at 1 minute interval at each points, as shown in this graph. In order to get to the point readings at desired heights, custom designed instrument holder was designed. This research data acquisition was conducted in 12-acre land in Akkarvelli in Putlam district. Data readings were compared with World Health Organization Ambient Air Quality Guidelines 2022 Global Update. Fine particulate matter, formaldehyde, nitrogen dioxide, carbon dioxide, and sulfur dioxide, total volatile organic compound threshold levels were taken into consideration. Moving on to the results and discussion, carbon dioxide levels, higher carbon dioxide readings were measured from 1 to 6 to 8 meter heights in paper and plastics. However, low carbon dioxide concentration when open burning organic matter. Carbon dioxide emission concentration were higher in plastics and lower in organic matter. As per WHO ambient outdoor air quality guidelines, more than 2000 ppm concentration is considered as critical. In this study, carbon dioxide emission concentration were recorded below 2000 ppm. The red color line shows the threshold levels of WHO ambient outdoor air quality guideline levels. Fine particulate matter PM 2.5 levels. Significant levels of PM 2.5 readings observed when paper and plastic were openly burned. Higher PM 2.5 readings at 6 to 8 meter heights in paper and inorganic matter, but in higher plastic emission readings from 1 to 3 meter heights. Therefore, PM 2.5 readings were higher in paper and low in organic matter. As per WHO ambient outdoor air quality guidelines, more than 150 micrograms per cubic meter concentration is considered as critical. Total volatile organic compound levels. Emissions of total volatile organic compound from paper and organic matter were less than 1 milligram per cubic meter. Plastic emitted the higher than 1.1 milligram per cubic meter at 1 to 6 meter heights at 2.5 distance from the burning point. As per WHO ambient air quality guidelines, more than 1 milligram per cubic meter concentration is considered as critical. The conclusion of this study from the results update considered household waste, plastic were the highest, and the organic matter are other source contributions. It is concluded that safe distance measures from open burning site is from horizontally at 5 meter distance. The future framework of this study is aimed to design public policies to control household waste burning. We assess the health impact generated by this activity. It may provide awareness and knowledge that require unsafe open burning and safe distance measures. And these are my references. Thank you for listening.
Thank you very much. Very important and timely important presentation. Topic on the waste air pollution by waste burning. And now the presentation is open for questions.
Chairperson, may I?
Yes, madam.
Now, here in this research, I'm sorry, I couldn't see your name there. Sorry, the presenter's name?
Jonathan.
Jonathan, did you consider only the carbon dioxide and PM materials there when burning plastic?
Yes, madam, I considered carbon dioxide, particulate matter, and volatile organic compound levels at that moment.
What are the volatile compound organs you got there? Did you categorize them?
No, madam. Just formaldehyde was taken into consideration, but mainly from plastic and polythene emissions, it is considered that the polycyclic aromatic hydrocarbons emit in a significantly high. But at the time, I couldn't find a way to measure PHS and polycyclic aromatic hydrocarbons.
Actually, burning of plastic is not environmental friendly, not only because of carbon dioxide emission, not only because of PM 2.5 emission and things, but there are many
dioxin
hazard, health hazard hazards are coming there. You did not consider all these things, no?
At the moment, I was unable to measure few runs.
Okay.
Therefore, I didn't
Where
consider.
did you burn them? Where did you burn them?
Mainly polythene plastics, dried organic materials, and paper.
Yeah, where did you do this research?
In Karavelli in Putnam district, I openly burned the waste material separately.
You are far from that burning point. And no other humans are far from that burning point.
I was there from 2.5 meter, 5 meter, and 7.5 meter horizontal distances from the burning point, and used to adjust the meter, the pole from 1 meter to up to 9 meter height. So I was pretty close to the burning point.
I think it is prohibited now burning plastic in Sri Lanka.
Plastic and polythene both.
Yes,
Yeah.
The thing is that there is no way to recycling and proper system here established. So actually more than this pollution and all these environmental issues, so yeah, wasting our processed raw materials, right? So processed raw materials and papers, and they have been, there are a lot of chemicals used to purify these and process up to this raw material, and we can very easily recycle those things. And it is ashamed of actually the country like Japan. I'm sure that they are very, very systematic in their waste collecting in recycling. Although I saw that in Jonathan, who presenting some statistics that in Japan has also with some with issues with that. So I'm curious about that figure. Whether they have issues with burning out open source burning of these waste. A very rarely practice, I think, in Japan, because they have divided their in a week they have different days to collect different waste, and they are properly recycled all those waste. So therefore, so things to consider.
Okay, thank you very much for all the clarification discussion, information given to the discussion. And now we are moving to last presentation of the session 1. The topic is on effect of estimation of sugarcane leaf nitrogen using different vegetative index by multispectral image analysis. The group of authors are RMA Piyananda, CP Rupasinghe, KT Aryavansa, UWLM Kumarsiri. Now presentation is open.
Good afternoon, everyone. I am Asela Piyanandana. This is my final year research presentation. My topic is estimation of sugarcane leaf nitrogen using different vegetative indices by multispectral image analysis. I did my research under supervision of Mrs. Chinta Rupasinghe, Dr. Tilanka Aryavansa, and Mr. Lahir Kumarsiri. This is content of my presentation. Okay, let's have some introduction and background information about my topic. Sugarcane, scientifically known as Saccharum officinarum, is one of widely grown crops in Sri Lanka. It is mainly used for extract sucrose for sugar production. There are 4 main industries in Sri Lanka: Sevanagala, Kalwatta, Burana, and Atimala. Efficient use of crop resources such as fertilizer is considered as one of the main strategies to increase the overall yield and income of crop cultivation. Nitrogen is one of the most important nutrients that affect the growth and final yield of sugarcane. According to the present situation of Sri Lanka, our per capita sugar consumption is near 31 kilograms per annum.
So therefore, we need 700,000 tons per annually. But only 56,000 tons, that near 8% of the total requirement produced in the country. So near 172 US dollar million is spent each year to import sugar. And also our average cane yield is 55 tons per hectare, and also our recovery rate is 8.2%. When we comparing field survey methods for sugarcane plantation, we can identify drone survey is the most reliable method, and it gains lot of advantages than other methods. We can use drone technology almost every step of sugarcane plantation. You can see according to this figure, the whole process can be effectively affected by this technology. The Sri Lankan sugar industry has several causes that threaten its long-term viability. There are lack of labor force, rising production costs, farmer use of outdated technology, have limited knowledge of modern production technology. This is the problem statement. In Sri Lanka, traditional agriculture monitoring systems had limitations in terms of expert individuals, labor shortages, time consuming in the field. To overcome those issues, new technological ways should be implemented. My objectives of the studies is to evaluate the effectiveness of different vegetative indices to estimate the sugarcane leaf nitrogen and to select the most suitable vegetative index for estimate the sugarcane leaf nitrogen. Let's move to the materials and methodology part. I did my research in Sugarcane Research Institute, Davalava, Sri Lanka. There I did mainly 5 experiments. First one is sugarcane leaf sampling. Second one is UAV image capturing. Third one is testing leaf nitrogen. Fourth one is image processing and map development. The last one is imagery analysis and regression analysis. This is my study area. I selected this area because it is the ongoing research land, its different nitrogen levels, and also sugarcane cropping when growth stage 1. My first task is leaf sampling. I collected leaf sample to determine leaf nitrogen. I collected 128 samples, that is 2 samples from each plot, and also I got GPS location. I collected sample where I collected sample. After that, I preparation sample to determine leaf nitrogen. After that, I did the leaf nitrogen analysis test. I used modified Gerdal method to determine nitrogen values. There is the analyzed data of sugarcane leaf nitrogen. My next task is UAV image capturing. To capture image, I use Phantom 4 multispectral DJI drone and DJI Crow software, and also VRCK2 mobile station and NT-RIP compatibility. I took images in 2 heights, 35 meter and 50 meter, and I used drone during 9 a.m. to 11. I processed that collected image using Agisoft MetaPace professional software. Using this software, I prepared 6 band photomosaic images separate in 2 heights. After that, using URSAE 10.8 software to develop one vegetative indices map and then cluster calculation. In this study, I selected there are 5 vegetative indices: normalized difference vegetation index, green normalized difference vegetation index, soil vegetation index, chlorophyll index green, and ratio vegetation index. There are formulas of those 5 indexes. After that, I developed both height vegetative indices map using URSAE software. After that, I extracted vegetative indices values from 1 meter square sample plot where the leaf sample was collected. This is the final data collection, which contains nitrogen values and vegetative indices values in both heights. Let's move on to the result and discussion part. In this research, I using Minitab 17 statistical software for my statistical calculation, and simple linear regression is used to model the relationship between 2 continuous variables, leaf nitrogen and vegetative indices. First of all, I looked at the scatter plot to get idea about which regression methods I use for calculation. Those scatter plots okay to go to simple linear regression. In here, I show the PIG has the most close result. After that, I did regression calculation. In here, PIG got the highest R-square value in 35 meter, which is 80.14%. I did same procedure to next height. In 50 meter height, also PIG got the most close result in the scatter plot. And regression calculation also CIG got the highest R-square value, this 68.3%. This is the final regression result of 35 meter height. You can see CIG got the highest R-square value, and this is the final regression values of 50 meter height. This is the 68.25%. Let's move on to the conclusion part. From the results, it can be concluded that the vegetation indices chlorophyll index being had high correlation to sugarcane canopy nitrogen content, and chlorophyll index green was identified as the most suitable vegetation index that can be incorporated with UAV technology based on multispectral camera, and the height of 35 meters is more suitable when compared to results. These are references which I use preparing my presentation, and thank you very much for your kind attention.
Thank you very much, Mr. Piyananda. Now, presentation is open for questions.
Marcel, is that you give this general conclusion that 35 meter is better. So what does that mean? That any type of drone and the hyperspectral camera will have this 35 meter?
No, sir, I selected both height is normally in foreign countries, they use 35 meter and 50 meter for their research. And therefore, I use that both height and in.
Out of those two, you finally conclude that 35 would be fine.
Yes, sir.
Right. Okay. So we have a question from Kuroki Sensei.
Yes, please.
Yeah.
May I have a question?
Yes, sir.
You showed a very beautiful result using the CIC is linearly related to the nitrogen concentration, but you have a lot of wavelength spectrum. You have the red, blue, green, and red range, and in NIR, which indicates that you can do the multivariate analysis. So did you try such kind of analysis?
Marcel, did you do multivariate analysis? Because you have a number of wavelengths, right?
Yeah. You don't need to rely on the NDVI, CASG, such kinds of the already developed index. You can develop your own indices. I think.
Exactly. That because while you are using that many number of indices, that means you have data.
Yeah, you have the lot of experiment variance.
Yeah.
Maybe if not, please you can try. Then you can develop your own index instead of the CAG. But you may develop much better indexes. Then if it's possible, I want to know why it's possible. Please.
Okay, thank you, sir. I will try.
Thank you. Thank you.
Thank you very much for your input, Sensei.
Yes. Thank you very much for the inputs for the research. Asel, a good idea is your eye-opening by the comments given by the Professor Kuroki. Is there any questions? If there are no questions, I think we are reached to the end of session 1 of the URSAE 2022. And actually today we have a very good sessions with very interesting sessions with different kind of research inputs of undergraduates, not only from Sri Lanka, even from the Sultan Qaboos University from Oman, even Professor Kuroki. Next time we hope to get the undergraduate student from your supervision also to participate our URSAE 2023. I hope that you will participate with some students. You can guide your students to participate URSAE 2023. Then we can more globalize the event. We hope to globalize event more in coming future also. Therefore, we wish to have your students also next time. And today we have very good presentations, very good research findings actually. Those are, it's a kind of expand our the research era. That is, there are some research from the Sultan Qaboos University regarding the globally exchange some information related to development of garden leaf collector and lime sorting machines, and also solar powered remote controlled sluice gate for irrigation purpose, opening sluice gate, and minimal processing of cucumber. Those are the main some of the research area the Sultan Qaboos University students are share with our in this forum. And also there are some other undergraduate also some research studies are there, and some flood inundation analysis. Actually, in some areas, actually that is very vulnerable for the flood in Sri Lanka. In Ratnapur area, some studies, one studies there, and also assessment of non-pollutant source in Kalani River Basin. Regarding that, actually regarding anthropogenic activities, there are many pollutants happens. Therefore, how it affect to our rivers, and also another studies there on groundwater quality on Kiramara River Basin. That is also one of the main river basin in Sri Lanka. Even especially this is important for southern province because it may how it affect to groundwater contaminations studied by that study. And also there are a few studies relating to indoor heat reduction. There are some undergraduate studies focused to internal clay wall, how to reduce the thermal insulations, and also that thermodynamic heat reduction from facades opening in multiple levels, and also air movement over concerning the opening of tropical buildings, different levels of tropical buildings, and also use different grass types as a thermal insulation in the building. Those are some of the research area already conducted by our students. I think most of these findings can be in future real world application. Even another very important topic today presented, that green consumer behavior for sustainable consumption and production. We know that all of as the country, even not only country, even as the globe, we unable to survive without sustainability. Therefore, we have to change our pattern, especially as a green behaviors. Therefore, then by changing our the behavioral patterns into green consumer behaviors, and we can have achieved sustainability. That is also very good because she is giving some scorecards, some values, and even by changing some behavioral change, even today I am driving car, but tomorrow if I can walk in, I can see what is the value for value I contribute towards the sustainable consumption and production. And then another thing is that another research study is focused to development of hypothetical cultivar using EPSI model, because I think even as a country, our yield level is always lower than the region level, even all the type of things. Therefore, it is very important to think about the hypothetical cultivars to have a better yield, because we have to get high land productivity. Therefore, it's very important to work on such type of studies. And also another studies focus, research finding is focused to smart monitoring system in nutrient film technology in hydroponic system. This is also very important nowadays. I know that we should move towards the closed agriculture, not in the open agriculture, because open agriculture we have very constraints are there. Therefore, if you can focus to open agriculture using smart technologies, then we can have a higher yield, vertical gardening, something like that. Therefore, it's very important to have such kind of technologies. Therefore, then we can move towards the higher agricultural productivity. Even another study is focused to the air pollution due to open burning of household waste in Sri Lanka. Like it's actually now, yeah, a kind of very low level of economy level. Even most of our the domestic level peoples, actually they are burning the things, waste, household waste. It is very important to focus that study how much it is polluted to our environment. Therefore, that is also we have good insight of the management of the waste. And also finally, we are discuss about the estimation of sugarcane nutrient content by the multispectral image analysis. Actually, Professor Kiroki give very good suggestions why we are depend on the given indexes. Actually, we can develop some kind of our own indexes to give some the kind of nitrogen content of the fertilizer. Actually, that is can be applied for next time for the fertilizer application as a feedback of the field about the nutrient condition. Then we can move towards the precision agricultural technologies like that. Actually, all when we consider about the all over today, we have a very good findings. If you can move with these findings, definitely we can have a better future. Okay, then thank you very much for giving me opportunity to share this session one today. And that's all. Then thank you very much.
Thank you very much, Madam. It is with the immense contribution of many, today's event has been made possible, and they truly deserve a sincere appreciation. On behalf of the organizing committee, I'm extending a really hearty vote of thanks. First of all, I would like to extend our sincere gratitude to the keynote speaker of the session, Professor Hemanta Jayasuriya, University of Sultan Qaboos, Oman, for accepting our invitation and sharing his valuable thoughts on automation and precision control in agriculture. Our sincere thanks to Professor Kuroki Sensei from University of Kobe, Japan, for joining us today. Sir, your valuable inputs are highly helpful to our students to widen their research horizon. Our special thanks to Senior Professor Sudas Divanniyarachchi, Dean, Faculty of Agriculture, University of Ruhuna, for his inspiring words and for being supportive to us in all way forward. We must mention our deep sense of appreciation to Senior Professor Jiva Jayasinghe, Head, Department of Agricultural Engineering. Sir, we are overwhelmed with your tremendous contribution in all possible means. Also, we convey our sincere appreciation to Dr. BMS Jinendra, Coordinator, URSAE 2022, for his active involvement and untiring efforts to make this event a resounding success. Next, we would like to say a big thank you to the chairperson of the session, Mrs. C.P. Rupasinghe, Senior Lecturer, Department of Agricultural Engineering, Faculty of Agriculture, for leading the scientific session successfully. We are grateful to Senior Professor Champa Ramaratne, Editor-in-Chief of URSAE 2022, and the editorial board members for their enormous contribution in preparing an impressive and informative proceeding. Our sincere thanks to the computer unit of University of Ruhuna. We have been fortunate enough to have them because without them, today's event have not been possible. Next, we would like to say a big thank you to the all department staff members. We have been fortunate enough to be backed by a team of very proactive and dedicated members. Our sincere thanks to our budding young scientists for making the session highly interesting with their competitive and excellent presentation. Further, extending our kind regards to all the participants for adding colors to the event. Once again, thank you all for your contributions in numerous ways in making this event a productive one. Ladies and gentlemen, we have arrived at the conclusion of the first session of URSAE 2022. The session will conclude with the national anthem. Please honor the national anthem by staying silent.
Jana
Thank you very much for joining us today. It has remained a pronounced pleasure. We will meet you all tomorrow on the second session of URSAE 2022 on emerging environmental technologies, with a keynote speech being delivered by Professor Alex Lichner, Associate Professor in Urban Design from Monash University, Indonesia. Hope you had a fruitful day with the first session of URSAE 2022. Goodbye, stay safe.